that's not a stand, those two are two very successful ones, but that conversation was happening all over the place. It didn't just pertain to the chain level or scalability level. It also went into tooling and other areas. And now we're at this point where as a developer, you can just come and build for Ethereum. And so there's so many more tools and infrastructure, scalability components at your disposal. You actually can just get to work on what you need to do to, get users. At the infra side and the more kind of like, these component parts around Ethereum, I think the conversation I've seen has really changed from 3 years ago. It was this hypothetical, like, intelligence Olympics, where everyone was just getting these theoretical arguments about what was best. And it was, everyone had kind of centered around either monolithic layer one or rollups, and one of two types of rollups. And that was just it. We're now living in this age where there's a lot of hybrid models. There's a lot of talk around app chains and multi-chain environments, modular environments, elastic networks, linear scalability. There's I think the scope has changed around what is possible, but there's also thankfully more of a discussion about, well, what actually is working? Because if you just have a great idea and it's not doing anything, no one cares. So I think we're at this point where, traction matters. So it's not just how good's the idea, how good's the tech, how much is it being utilized? About a year ago, also, I say there was a renewed focus on UX, and UX was a big, big topic. And now that UX topic and discussion and argument really kind of gets pulled back into, okay, well, show me your UX. How many users do you have? How much, how many trades are happening? How many, people are playing this game every day? How many people are using this application every day? So we're starting to see the UX in action. And it's, again, thankfully, less of a hypothetical, philosophical debate. I think the next phase at the infrastructure level and all the related component parts around Ethereum are going to be about decentralization again. I think a lot of people forgot about decentralization. They're very focused on UX. I think a lot of our core first principles as blockchain builders kind of got swept under the rug because we're like, hey, we got to get users. Obviously, I think people here haven't forgotten about that, but I think you're going to see a renewed focus on those core principles. That's my 2 cents there.
Awesome, great. Anything to add, Elena or Tyler? No. All right. Elena, we'll go to your question. So what do the teams look like? What are the roles? What are the skill levels that we're sort of seeing that you think on your team and elsewhere that you're seeing very, very important?
Yeah, I think it's largely the same. Most of our engineering or most of our team makeup isn't actually engineering. So I kind of want to rephrase the question a little bit of like, what do those employees want to see out of your project, which might mirror a little bit what you said. Like the one comparison I like to make is like AI right now is quote unquote the new crypto. And I like to say that because like, back in like 2021, valuations for like crypto companies were, sky high. And now we're kind of seeing the same pattern in AI. And when I said that to someone, they pushed back and they were like, well, AI actually has usage and that kind of hurt. And, like if I were to ask you, like, make this a little bit more interactive, like how many of you have used like ChatGPT or Claude or whatever in the last like week? Yeah. How many of you have used like Ethereum in last week? Okay, fine, bias crowd. but in general, if you were to ask like the average user, I mean, people use like AI way more than people use crypto, even though it's like quote unquote like kind of parallel in terms of being new in this novel technology. So back to the question of like, what do the employees actually need in crypto companies is to see like more usage. And like at Ironfish, I think we've been extremely like great, or I've been extremely grateful for the team that we have because they are very like mission aligned. And despite like, price and bear winter and like all the negativity like we might be seeing around crypto today, my team actually has been extremely positive, which is like, very heartwarming to like come to work and like have people be actually excited for what they're doing. But the pushback is like, well, we need to see usage. And for crypto companies in particular, it's actually really hard to understand when you have product market fit, because if you're pre-mainnet, you're going to naturally get users because they think there's going to be an airdrop. And so you're not sure if you're product market fitting or if you're product market fitting to people thinking you're doing an airdrop. And so a lot of projects are going to see this phase of like having pretty massive quote unquote usage before mainnet and then having like questionable usage after mainnet. And there's all these questions of like, well, is this the market? Is this like my product? Is this my users? Like, what's going on here? And like that actually is actually pretty hard to navigate. So kind of like what you were saying in terms of like now we're having this reversal of like, well, should we be focusing more on like quote unquote centralized technologies? Like maybe having rollups with a single sequencer is like not that bad because like that gives us more energy and more focused and actually build a better product. And like for gaming in particular, like should we be really focusing 99% of our engineering into making sure it's decentralized, or should we be focusing on like making sure it's a good game and then figuring it out later, or maybe hoping that Optimism is going to figure it out later and you can kind of port to that. And so I think like right now we are in this phase where I think it's actually healthy, where most teams are forced to try and build good products because there's no longer this like hype cycle of people thinking there's going to be airdrops everywhere to a large extent. So I don't know if that answered your question completely, but
it was good. Although I think, Jack, did you want to add about her point about the hype and you know when it comes down to transactions and what you're seeing in a layer 2 space?
Yeah, I'd just say we have users. Okay, we've got a lot of users. If you go look at DAP Radar and look at the top 30 applications and like count up the amount of unique active wallets and compare that to a year ago or 2 years ago, you're gonna see dramatic growth. Okay, now is there a lot of like astroturfing, whether you're a game or you're a DeFi project, et cetera? Astroturfing means instead of grassroots from this artificial grassroots. And yes, I think there are a lot of airdrops and a lot of usage competitions, and a lot of things applications are doing and protocols are doing to try to gather users and incentivize them. And what's really going to be telling is when those incentives go away, will people keep using it now? And I think no one's ever paid me to use ChatGPT, but I use it, but I also think there's so many killer use cases in blockchain that we're going to see that, but it takes a little, you got to stare closely to see what the real traction is as to look past these like incentive mechanisms.
Yeah, I think also important to note is that a large number of companies are now moving away from some of these incentive mechanisms. You can see it in a lot of the new L2s where you look at their website and there's no mention of an airdrop, right? They're sort of phasing that out, but they're still getting the usage. And that sort of implies that a lot more of the growth that we're seeing this year is less AstroTurf than it was in previous years. The growth is still there, the usage is still there, but the incentives have actually been reduced or gone away already. And I think we're just going to continue to see that. And hopefully that means that there's going to be a lot more organic and real growth that we're going to sort of realize in a couple of years, 2023 was actually this great year for like true growth in Web3.
Great. Okay, so Tyler, to you, what should builders be focusing on in 2024? There's a lot of stuff out there. There's a lot of noise. How would you suggest simplifying it to where developers should be spending their time looking at, or whether that's tooling? How do you make their lives easier?
Well, so that's actually what we're working on at Cookbook. But to sort of like make it a little, try and like break it down into like 3 chunks. It's primarily like frameworks, just frameworks for development, frameworks for testing, and then sort of like discovery. So like the key thing there is you want to be able to, and I'll start with discovery. Like you want to be able to find out what you do not know more quickly without needing to sort of like browse the internet a lot. So I think there's a lot of like neat discovery tools here that are sort of like bringing things more into the limelight. You can see this a lot where a lot of these L2s, and this has been around for a while, but they'll have ecosystems pages that will allow you to really like find the tools that you're looking for. And that's really how you discover like pretty much like the new main sort of important technologies to be using for developers. Like a lot of this is really boils down to like, in the case of like development frameworks, like people are now using Foundry way more than ever before. It's really taking over. Auditors are really like asking developers to all migrate everything to Foundry and not use hard hat anymore, or at the very least, like upgrade their hard hat configs. So this is something where it's like developers want to be aware of like, okay, how do they discover these new technologies? How do they sort of like get involved in sort of like these development frameworks, these up and coming ones like Foundry? Another important one to note is Atlas IDE, which is really sort of like trying to take in new developers and make it much easier for someone to go from zero to hero in Web3 rather than just catering to the hardcore devs who will stay up all night 5 days a week and sleep just on the weekends. So, and I guess the final aspect of that is really testing frameworks. This is something where as security vulnerabilities and security exploits increase in sort of like magnitude, as TVLs increase, just naturally as the space matures, you really just need improved testing frameworks. And like there's a couple of like really promising companies in that space, like BuildBear and Fuzzland, really sort of like providing a lot of that infrastructure for testing, which is going to be just as big or much bigger than just these development frameworks, because at the end of the day, you really need to know that whatever you're building is going to be able to support billions of dollars in TVL without having any major vulnerabilities.
Okay, that's great. So we got one last question to you, and then we'll move on to the program for Elena. First, talk about what talk you all are giving, and then which one you're looking forward to that's not yours.
Yeah. So, sorry, I missed
You're doing a roundtable on developer relations.
Yeah.
And is there any particular talk? You mentioned Foundry. There's a Foundry talk here. You mentioned Fuzzland. There's a Fuzzland fuzzing patterns. Are there any others on the agenda that you saw?
Well, I'm a little biased. I'm a big fan of both of those, but I'm looking forward to Elliot's talk on solidity patterns.
Yeah, that's the Foundry
Yep.
patterns. Awesome, cool. Okay, Elena, what are you speaking on, and which one are you looking forward to?
Yeah, so I'm going to be talking about privacy patterns. So Ironfish is a privacy protocol, so I'll kind of talk about that. And then in terms of things I'm looking forward to, cross-chain intents seem pretty good. So for Ironfish, that's really top of mind. We're trying to bridge to other chains so that Ironfish can be this privacy pool for other chains as well. So it's definitely top of mind.
Is Henry around? There he is in the back. All right, he's speaking later in the day on cross-chain intents. And then Jack, what are you speaking on, and any that you're interested in?
Yeah, I'll be talking about gas patterns, and I think there's a lot of ways that people are trying to abstract complexity away for the end user in terms of gas. And Scale, for example, has a chain fee model. Validation fees are paid at the chain fees. I'm going to be talking about that. And I think, as an example, I think we had about 10,000 active wallets prior to June 2022, and I think there's been like 4.5 million roughly in the last year and a half. And I think a lot of that is attributed to this type of gas pattern. But I'll be talking about more than Scale, other patterns for those that are interested. Both of your sessions, I'm really excited to hear about. Also, Dawn's audit, smart contract audit. That's always this rapidly evolving space. I also, the on-chain liquidity patterns looked interesting to me. Something I'm interested in.
All right, is McDavid here? Awesome. Cool. There you go. All right. So we're going to go into the program officially, and Elena's up here talking about privacy. And then we've got Dr. Shuyu Lu, and it's going to be ETH call RPC patterns in the boardroom. So the talks are going to be here, and then the boardroom, and then the round tables are going to be after the break, and they're going to be spread around the space. So you're just going to have to find out where they are. All right. So hope you have a great rest of the day, and yeah. Let's have a good day. Thank you.
Okay, I think I can use this one. Okay, cool. Thank you so much for joining me. We're going to be talking about privacy patterns in zero-knowledge proofs. So just real quick, for people who may not be familiar with what zero-knowledge proofs are, I think at this point, probably most of you are, but let me just kind of go over this real quick. So zero-knowledge proofs are the idea that you can prove something about hidden or encrypted data. And in like 2017, zero-knowledge proofs were conflated with the idea that zero-knowledge proofs equals privacy. And I think at this point, maybe it's conflated with scalability. It's actually none of those things. Zero-knowledge proofs prove honest computation, and it's a tool that you can use for many different things, such as privacy or scalability or anything else. So I'm going to go over what is privacy in crypto, because there's a lot of different ways to do privacy in crypto, and I think people fail to understand why we have transparency in crypto. So let me just go over very quickly how UTXO chains do validation with transparency. So let's say you have Bitcoin, or I don't know, Bitcoin with dollars, and you have a $20 bill, that's yours, and you want to give your friend $10. So what happens is this $20 bill is now an input to your transaction, and it kind of gets ripped up. So we use it, and what happens is there's two new notes or UTXOs that represent $10 that you want to give to your friend, and then $10 back to yourself as change. And then this pattern continues. So if your friend wants to spend their money, they rip up their $10 bill, and so on and so forth. And so the reason why we actually require transparency here is a validator needs to see, like, well, where did you get your $10 bill? Oh, you got it from your friend who had a $20 bill, and he got that $20 bill from actually mining a block. So whenever you mine a block, that's actually the origin of all the coins. And so we need transparency, and that's pretty inconvenient because that means that blockchains are inherently transparent. So if you think about like building is unbiased, like, cross-border payment system, all of a sudden it's kind of like Venmo in public, and it's really hard to imagine that world where businesses or individuals would want to use crypto for real when everything they do is out in the open. So transparency is key for validation for these chains. This was an example for UTXO chain, and for account-based models like Ethereum, it works at a high level pretty similarly. You'd still need to see the history in order to validate, even though it works in a different model. So zero-knowledge proofs let us replace the transparency requirement with the idea that I can now prove to you cryptographically that something is accurate without actually showing it to you, meaning that I can give you an encrypted blob and say, like, well, even though you can't see it, I can prove to you that the transaction was constructed correctly, for instance, or that I'm spending funds that I actually do have without showing you anything else, like who I am, where I got the money, what the money is that I'm spending, etc. So instead of this pattern where I take my $20 bill and I rip it up and I show everyone that it's mine, it's actually this pattern. So you still kind of see the number of inputs and number of outputs, but you see nothing else. Everything is encrypted. So the input kind of bill that I'm using is encrypted, and the output bills that I'm sending to myself and to my friend are also fully encrypted. And now I'm actually giving you a zero-knowledge proof saying that even though it's encrypted, I can still prove to you that I have this dollar bill or $20 bill, that I've computed the $10 bill accurately and correctly such that my friend can actually receive it and I can receive mine, and I haven't spent it before. So we actually can do all those things using zero-knowledge proofs. So that's pretty great. So I kind of want to shift gears a tiny bit and show you kind of a little bit of the landscape of crypto. So these are just like some NFT projects. There's like thousands of them, like literally thousands. There's a ton. In DeFi, I just wanted to say this. There's over 9,000 projects that just do yield. There's like a lot. But for privacy, there's like not very many. And this is like from 2016. Like we have had like a long time to work on privacy in crypto, and we have like maybe 24. I don't know, roughly that. And I might have missed some, and I'm sorry. But the idea here is that there are very few of them. So the question is why? Like, it seems so important that we need to focus on privacy. Why is it so hard? Especially since like we kind of have a pattern for how to do privacy. Like Zcash kind of pioneered this pattern. Like why aren't there like more projects focusing on this? And the answer is it's pretty hard. So there's kind of like not even a trilemma. There's like 4 things I think you should hit in order to have like a pretty good product. And it's having a good UX, especially for privacy. It needs to be accessible. It needs to have a high degree of privacy, meaning that you're not like you're marketing the product accurately to people. And I think like, especially post 2023, we kind of all realized if you're working with privacy, it has to think about compliance in some way to make sure that bad actors don't use your product, because privacy is indeed a double-edged sword. So for good UX, what I mean by that is, how easy is it to use? Like, do I have to have a PhD in cryptography to understand how to use a product? Do I have to use Tor in order to use your product? Things like that. Compliant basically means, if I'm a regulated entity, can I use your product and still stay compliant? How do you prevent North Korean hackers to use your product, and so on? Accessible basically means like, can I run a wallet easily? Can I get access to the coins easily, and so on? And then high degree of privacy basically means like, am I marketing the product to users correctly? Am I saying it's private, but I know for a fact that they have to use a very particular pattern in order to get the privacy? And if that's the case, then I would say it's not that private. So humble brag, at Ironfish, we're trying to hit all four. So we're trying to be in this little section here. But it is actually a pretty hard journey for how to get there. And so this talk is about privacy patterns. And so I do want to focus on that. So I would say that as of now, most notable privacy products that I think are actually good and actually are hitting those things that I mentioned before, all operate in this idea of privacy pools, which is kind of what I described earlier, of using zero-knowledge proofs and encryption to have these notes that are then spent in a certain way. So for instance, Tornado Cash, Nocturne, many others, and even Aztec and Alio actually kind of are following this like pattern that was really pioneered by Zcash back in the day, of having this like, a pattern for how to do privacy pools. For privacy pools, we can kind of think of this as like a very broad term to describe that you have this black box. So either be an L1 or an L2 or a smart contract. You can kind of think of a privacy pool as, I put money into the privacy pool and I'm just going to wave my hands for a moment and say, like, whatever happens in the privacy pool is very private. In practice, it's not always true, because I think smart contracts on transparent chains don't have that property. But for a moment, let's just imagine that that's the case. So really, the biggest thing that I want to talk to you guys about, because I think this is actually missing from most patterns of privacy protocols, is how do you track the bad guys? And it's going to be a little bit interactive, because I want people to understand how hard this problem here is. Let's say for a moment that it's 2021 or 2022, I don't remember anymore, and the Ronin Bridge hack is happening right now, okay? There's a hacker, they just stole $600 million worth of like ETH, and they're trying to launder it, and they're trying to use a privacy pool, or any, like your privacy pool, let's say, to launder this money. What do you do? How do you prevent the bad guys from using your product? And if we assume that anything that happens within the privacy pool is really private, then there's really only two things you can do. You can try to catch the bad guy when they're trying to go into your pool, or you can try and catch the bad guy when they're trying to exit the pool. So it's going to be interactive. Let's say you are a developer of a privacy pool protocol, and you are seeing that North Korean hackers are using your product to launder a bunch of money. And you're thinking, okay, well, maybe I can screen transactions on the ingress, meaning that when people are entering the privacy pool, there's something I can do to try and stop them. So let's say you're seeing bad actors trying to use your protocol right now. What are some of the challenges that you might foresee with a strategy? Okay, you.
It's kind of a question, I guess, but so if you don't catch them right away as they're coming in, is there some sort of log that you could go back later and look at it, or are we assuming that that's just not allowed?
That is a great question. So now you're basically saying, like, well, can we track activity within the privacy pool?
Retroactively.
Retroactively.
So if you didn't catch it all the way in,
yeah.
see what happened last week, and like, I caught you now, even though you snuck in.
Yes. So that's actually on the egress. So you're basically saying once the bad actor is trying to get out.
Or you caught that they got in.
Yes.
You catch it until a week later. Or is the privacy pool such that you're just not allowed to store something that lets you remember that they got in?
So you can store everything that like went into the privacy pool. For instance, let's say I'm address A and I went into the privacy pool and I'm withdrawing to address B. And most privacy pools, I think at this point, are pretty good in the sense that there's no connection between A and B. So even though you saw that like account A was really, really bad, but you're just seeing activity from account B, then you don't actually know that there's a link between the two accounts. Unless, of course, you try and make a tracking kind of solution within the privacy pool. But that's really hard because either it breaks a privacy assumption that you just told to your users, or there's actually so much overhead on the protocol that like your gas fees are going to be astronomical. It's going to be like a lot of storage components to it and so on. So when we were thinking about this problem, especially on the ingress, it's really speed. So hackers are really good. Like if there's a hack that's happening, they launder the money in like 10 minutes. Like it's statistically, they literally launder it in like minutes. And so you as a poor developer, you're like what? How am I supposed to catch a bad guy when they move so incredibly quickly to launder money? And I don't remember exact like stats for the Ronin Bridge attack in general, but like in general though, like they move really quickly. So when we were thinking about this problem, we're like, okay, well, it's going to be a bad user experience, but what we could do is if you're trying to go into the privacy pool, we actually put you on hold for 24 hours to give us a time delay to catch up. Because like hackers, what they typically do is they go from wallet to wallet to wallet to wallet. And so even though there's one wallet that actually did the attack, your poor protocol like can't keep up with all the jumps. And so if we give a time delay, then we could potentially use like other companies that are actually doing this for a living, like Chainalysis and Liptic and so on, to try and like trace this is the bad wallet, even though they made like 100 hops. So that's like one way to protect on the ingress. On the egress, which means the person's coming out, kind of like what you were saying earlier, it's really, really hard to track whether or not the depositing wallet, like the wallet that's trying to go out of the privacy pool, was linked to the bad guy originally. And there are ways to do it, but they're like so technically hard. Like we've thought about this a lot of like, how do you like have a tracker within the privacy pool that like potentially can even use like fancy cryptography to be like, okay, like, you know, this money came up from a bad account and then Destiny becomes a problem, like, which actually is what we saw with Tornado Cash. Let's say I'm trying to infect the entire pool, then I can split the bad note into like 1,000 pieces and give it to like random users, and all of a sudden everyone's infected, and like that's kind of defeats the purpose. So this strategy is like really hard. And then this one, you know, we thought about this a lot of like, how do we put a tracker within the privacy pool? And you know, like we had Dan Bonet from Stanford actually like come and like work with us for like 6 hours trying to figure this out. And there is a solution, but it's going to be so like expensive in storage because you're basically saying like I put a tracker in every single note. That it becomes like kind of infeasible, like practically. So the solution that we kind of came up with was the ingress one. So if you're trying to go from Ethereum to Ironfish, you're going to be put on hold for 24 hours. After the 24 hours, we'll check whether or not you're the bad guy. And then you can go use your privacy pool. And yes, it's a terrible user experience because you have to wait for 24 hours, but then you'll have to wait 7 days if you want to exit out of optimism. So we're like, well, you know, double-edged sword. Cool. So the reason why I want to talk about this is because we actually don't really have screening patterns for privacy pools. Like there really aren't any. And I think like it's one of those things where we as an industry, or at least as privacy protocols, have to figure out how to do this because as of now, there's not really a go-to privacy solution for crypto. There's like pretty disjoint projects and disjoint L1s, and there are some smart contracts that are doing privacy pools, but they're very much not popular. In fact, still the most popular one is Tornado Cash. Like, is anyone willing to take a guess what rating they have on DeFi Llama right now, like Tornado Cash in terms of like TVL? Who would guess it's top 100? Like Tornado Cash. Is this still top 100 for DeFi? Okay, cool. It's actually number 40. It has 300 TVL, even though it's like sanctioned and the team is like gone, etc. Like that's how popular it is, even though it's like pretty much like, you know, like blacklisted now. So outside of that, like we don't actually have any other like a privacy solution for crypto. And I think part of the reason is because we don't really have a good like screening pattern. And like obviously we're going to pioneer the 24-hour holding period and see how well that does in terms of like user experience. But yeah, I mean, like we don't like have a good privacy solution, and we certainly don't have at this moment in time a good way to screen bad actors. But that is what we're working on Ironfish. Oh, go ahead.
I know some people have talked about. I know some people on the ZK podcast have talked about exclusion proofs to track egress, because you have to keep money in there anyways for a while.
So I believe and that's one of the things that are pioneered by Vitalik and Amin, right? Amin Soleimani. I don't remember how to pronounce his last name. But yeah, exclusion proofs basically is on the egress, right? So I'm saying as I'm exiting the privacy pool, I can give to you a proof that I'm not the bad guy. And we've thought about that a lot as well. And I don't know how they address it. But again, if I'm the bad guy, I'm going to hop 100 times before I enter the privacy pool. And it is like a time game. Then I exit right away before anything tracks me and say hey, I'm not a bad guy. I'm just this fresh wallet. So I'm not sure how they address it. And maybe I should listen to the podcast and see their commentary on that. But we couldn't figure out a practical way to do it on the egress personally. But yeah. Anyway, that's what we're working on. We're trying to figure out how to bring privacy to crypto. We believe privacy is a force for good. And if anyone's interested in learning more about Ironfish or even careers at Ironfish and so on, here is our Twitter handle. And we're always on Discord. We've been mainnet since April. We're currently working on cross-chain communication bridges, like I mentioned before, with what we believe to be the best solution for screening practices for us. And if this is something that's interesting to you, then please let me know. We're always on Discord, always on Twitter. So yeah, cool. Oh.
How does it differ from Tornado Cash beyond having a waiting period?
Yeah. So for us, we have. So let me just kind of back up. So for Ironfish, it's a brand new layer 1. Every single transaction is fully encrypted, meaning that it is fully private. We do have something called custom assets. So even though Ironfish is a UTXO chain with no official smart contracts language, you could still do very limited custom assets. So you can make your own ERC20, for instance. And the reason why we did that is so we can bridge to other chains and you can have a wrapped representation of Bitcoin or wrapped DAI and Ironfish in a fully private environment. So the question is well, how are you better than Tornado Cash? So there's various things that we did to make the protocol, in our opinion, more compliant. So every note actually has a sender. So for instance, let's say you're Coinbase and you're a regulated entity, you actually need to know exactly where your funds came from in order to make sure that you're not accepting money from a sanctioned address. So for us, every single node has a cryptographically proven sender on the note. So now you can check whether or not the funds came from a bad wallet. The other thing that we did is we have what we call as a full view key. So most privacy protocols have the idea of a view key, and even Tornado Cash had an idea of a record view key, I think they called it. And it's this idea that I have my spending key. That's the one I use to spend money. I have my public key. That's the one I use to request money. And my view key gives anyone the ability to see contents of my wallet. For Tornado Cash, the view key only worked per record. So for instance, a record there is a UTXO, a bill. So I can show you that this $20 bill is mine within the Tornado Cash pool. But that's actually a very limited view. And for us, a view key is a full view key. So you can see all the incoming transactions, all the details about those incoming transactions, all the outgoing transactions, and all the details about that. So we just have better compliance tools, so a regular entity could actually have proper bookkeeping to make sure that they stay compliant.
Maybe a noob question, but what's the answer to the question of if you're not a bad actor, why do you need privacy?
Oh man. There's so many answers. So in 2013, Moxie, who's the founder of Signal, wrote this amazing blog, and the blog title was "We all have something to hide." And the idea is that as of you are breaking laws every day, all the time, because you don't know what they are. If you're in Maine and you have a lobster above a certain size, that's a criminal offense, even to this day. And you might have gotten this lobster by accident, who knows? But now you're breaking the law, right? So that's one argument. For instance, the other argument is that sodomy laws were still effective until 2008. So if you were a gay couple in certain states, you were breaking the law, right? Unless you have privacy, and privacy lets you kind of change society in a way that you can amend those laws. Same thing for marijuana and so on, or even interracial marriage. People are able to break the rules in order to like change society. That's a pretty like aggressive argument for like why we need privacy. But well, sure, yeah. I mean, that's like one way of looking at it. Like, isn't like rule breaking like always bad? And so the libertarian argument is like, well, no, especially when it comes to like privacy, right? Like, there's certain things that are like our freedoms, and we should like fight for that. But that's a great, like, that's actually the juxtaposition of privacy. It is a double-edged sword. Like, protection for whom, right? Like for bad guys or good guys, and it's really hard to like to figure that out. Like, for instance, like when we say, you know, we want to protect people from their own governments. Like when I say that, I think of like, you know, if you're in an oppressive regime and you're trying to like protect your wealth from a dictator who's trying to take it away, like I would say that's a good thing. But if you're gonna take a few steps back, it's like, well, wait a minute, like, are we protecting people from their own governments? Like that could be potentially bad if you're, you know, in the United States. So it is like a slippery slope of an argument. But what I like to focus on is like a very pragmatic view, which is like we need privacy for like just good like business. So if you talk to like hedge funds, for instance, like financial privacy to them is like their entire business model. Like if you are a high frequency trader and you leave the business, they give you a 12-year like severance package just so you don't go to any other high frequency like financial institution, because they just want to protect their like orders or like their positions. Like that to them is like privacy. Financial privacy is like very much a business. And then, you know, there's so many things where like that they just should be yours. Like whenever people tell me like, oh, I have nothing to hide, it's like, well, I don't know if that's true. Like, would you really tell your mom that you bought condoms? Like, no, you probably won't do that, because there's certain things that are like either embarrassing for you, or you just want to keep to yourself. If you want to go to therapy, like that may be something that's, you know, should be like information that is only accessible to you and so on. But yeah, it's a great question. Anyone else? General comments are good too.
It's not a good question.
Okay.
People are going to leave the door open when they go to the bathroom.
Oh yeah,
It's normal.
exactly. Yeah. Especially in San Francisco, you should definitely leave your doors closed. Yeah, I mean that's a pretty common argument as well. Like if you have nothing to hide, then why don't you leave your door open? Yeah, I mean privacy is also very much linked to like property rights as well. Like if you can't protect it with privacy, and then do you really have it? Again, like the doors on houses argument. But yeah, I mean I think like it's just a kind of necessity for a healthy society. And we are moving to this like highly digital age where we're losing a lot of the privacy that we had in the past. In fact, I would say that as of now, we're kind of moving towards the future already. Humans have never been surveilled like this ever before in like the history of humanity. And like that is kind of, you know, breaking our psychology a little bit. Like if you look at how Gen Zers use like social media right now, it's even different than like our generation. And like, that's pretty wild. Yeah. Oh, go ahead. Yeah, so for Ironfish, everything's transparent. Like we've open sourced everything, so you can look at every piece of code we've put out almost. The only code that we have closed source is like ones that like is not ready to be like revealed to the world, sort of thing. But yeah, it's a great question. So a lot of times people close source not because of like privacy kind of concerns, but more of like if hackers know your product better, then they're able to attack it in a much more sophisticated way. So it's kind of a different level of privacy. But yeah, I mean, for us, like we're a crypto project, so it's almost a must. Yeah, I mean, sort of. So like, one thing that kind of reminded me of what you just said is like proof of reserves. So right now, a lot of exchanges are using not zero knowledge proofs, but there's actually a huge project that is trying to attempt to use zero knowledge proofs to give a public proof whether or not an exchange actually has the money that they say they do. And this is obviously after the FTX collapse. It's much more on top of mind. And even CoinMarketCap or CoinGecko, I think, like has a little symbol like check mark thing of like, do they have proof of reserves? So it's like a different type of privacy of like, hey, I want to prove to you something, but I don't want to reveal my entire like position. But yeah, zero knowledge proofs can help with that too. Cool. I think it looks like I'm all right. Cool. Well, thank you so much, everyone. Really appreciate it.
Test 1, 2. Oh, that's loud. Good morning, guys. GM. My name is Kevin Jones. I'm a DevRel engineer working for Edge and Node, working on the Graph protocol. I'm also an active member of the Build Guild. If anyone knows the Build Guild, anyone heard of ScaffoldETH? Yeah, a little bit. I help support that community as well. But today I'm going to be talking about specifically indexing. And specifically indexing patterns with the graph. There's kind of a lot of interesting stuff that's happening with the graph right now, and we're trying to find ways to like revolutionize this concept of indexing data. So first of all, raise of hands, who here has heard of the graph before? Awesome. Who here has written a subgraph? Okay, it's a little bit half used. Okay, so this is live footage of what the graph does. If we look at the blockchains specifically, there's a lot of going on, right? There's a lot of events, there's a lot of transactions, there's a lot of things that are being passed around on blockchains. And what the graph hopes to do is help organize this data in what are called subgraphs, right? These are like collections of data. The initial like architecture for a dApp is something like this, right? You have a application that you probably are deploying somewhere like on IPFS or maybe on like Arweave or Filecoin or some kind of decentralized storage. And then you deploy your smart contract, right? Which has all of your business logic on a blockchain, right? And this is great. And it worked great for a while. There was a lot of cool dApps that were built that way. But when it comes down to it, most blockchains are really not incentivized for reads, right? They're incentivized for writes, right? They use a JSON RPC interface, which is really designed for managing a node, right? And it's really not designed for reading data from the blockchain and specifically reading large amounts of data or organized data, right? You literally have to do kind of like a lot of tricky work to get the data you want using an RPC. And so this is where the graph comes in. The graph is kind of like this decentralized protocol and it is a middleware kind of layer concept where we expose an API layer for blockchain data so that you can still read and write from your smart contract if you want, but you have this additional layer and option to read the data from a decentralized network, an API. So again, the graph aims to be like the data layer for Web3. And we tried to stick to the ethos of crypto and the ethos of Web3. And so this is just a good example. Like this was actually some code we saw in the wild where someone wanted to, when a wallet would connect to their dApp, they just wanted to kind of list all of the NFTs that owner particularly had. And you know what you end up having to do with if you're doing ETH calls is you're having to loop over and get the balance and then create a loop of all of those items and then put them into an array. And then you can go ahead and display those in your UI. This is great if you only have, you know, a few NFTs in your wallet, but the minute you start to, let's say you're an NFT collector, not me, but I do have a decent amount of NFTs that I just buy for some reason. This could take 10 seconds, 20 seconds for your page to load, right? It's not efficient. So what we aim to do is do something like this, where we provide a GraphQL API for the data. Who here has heard of GraphQL? Raise your hands. Cool. So if you're a front-end developer, you know GraphQL is really highly optimized for front-end applications because you can exactly get what you want, and you can really, use the query language to optimize the data response that you want to get, right? And so the network right now, this kind of varies between different levels, but there's over 200 to 300 indexers at any given time running that are indexing data. And these are actually community members, people in the network that are not, any particular company, where they're all indexing data. There's also delegators, curators, which are people that are basically providing GRT to the network to keep it alive. And then there's over 1,000 subgraphs that are being published or have been published to the network. So you can kind of think of the subgraphs as APIs, and I'm going to get into it a little bit more. And we do have the hosted service, which is like a hosted way to store subgraphs, but that is going away. And we're focused on improving and making the quality of service for the decentralized network the optimal way to actually deploy your applications. And this goes back to the ethos of Web3. We want to create a decentralized network, which truly makes applications truly decentralized, right? Trying to get away from this concept of Web 2 and storing stuff in a private database and whatnot. So there's a lot of other protocols that are migrating over to the decentralized network. There's just a few here you could probably poke out. POAP is one of my favorites. Who here collects POAPs? POAPs are great. But yeah, so a lot of protocols are moving to the decentralized network. And yeah, we're at this point now where we're really trying to increase the developer experience and make it easy for people to index data onto the decentralized network. And that's what I'm going to get into today. So there's also a bunch of chains that we support. Coinbase also is not on here. Base Network is also one of the chains. And so if you go to thegraph.com, you can see a full list there. So who's working on the graph? So this is always a quick question that people don't know, but there's actually a lot of companies involved in the graph protocol. Me working at Edge and Node is one of those companies. We support Graph Node, and we support the developer relations aspect of a lot of the graph. We have Masari, which does standardized subgraphs. We have Pinex, which does infrastructure for a lot of the graph network. We have Semiotic AI, which is doing some really cool stuff around zero knowledge proofs and snarks. We have the Guild, which is also a popular Web 2 company, but also highly supports a lot of our tooling. And then we have Streaming Fast, which I'm going to talk about in a little bit here. And then GraphOps, which does GraphCast and the indexer Launchpad as well. So there's a lot of cool companies, and they've actually opened it up that anyone can be a core dev. So if you are launching a company that somehow supports the graph, you can actually become a core dev pretty easily. So the main goal for the graph is to keep the quality of service of our data that we make available as high as possible, lower the cost, keep it at a reasonable rate, and then also make the developer experience reliable and trustworthy. So, okay, so that's all about the graph. Now let's get into the nitty-gritty. So when we talk about indexing data, right, there's the standard approach that is kind of how the graph was founded, and I think a lot of people are probably familiar with this method, right? And it's using a JSON RPC. So we can think of the data pipeline as an ETLQ pipeline, right? This is how we process data, right? We extract the data from some location. We can transform that data if we want to, right? We can use some kind of programming language to transfer it into different schemas or buckets, and then we can load that data into some kind of database that we want to get access to, and then we can provide some kind of query layer for that, right? That could be an API, that could be a Postgres database, it could be whatever, right? So we go back to this concept of the blockchain, and the blockchain is a sea of transactions and stuff going on. It's very busy, right? And it can be very difficult to look through a block and really get the data you want. And so we came up with the concept of a subgraph originally. And so a subgraph is basically all of the event data or perhaps off-chain data, like if it's on IPFS and Arweave. You can create these subgraphs, which will listen for these events or listen for this data that's being hosted somewhere off-chain with like a decentralized network, and then put that into a subgraph, right? And so if we look at subgraphs, right, specifically, what we do for the extraction is we query a JSON RPC, right? So, you know, the Ethereum network, right, has a JSON RPC that you can query and listen to events that are being posted from your application. And any good Solidity developer probably creates events for their application. We can listen for those over JSON RPC. We can also get access to like the blocks and the call handlers as well. And we can use assembly script, which is a WASM module that can run on the indexers that can process that data, right? And we can store that using a specific schema type where we keep track of data types and put that into PostgreSQL, right? And then we can expose that with a GraphQL API, like we showed before, right? And this is what the Graph Node does. If anyone's heard of the Graph Node, it is a tool that is used on the indexers. The indexer stack, I'm going to go into it a little bit more. But this is kind of what we aim to do, right? We look at the original idea of a DApp, right? But we kind of like break the queries and the transactions into two different paths. So you're still proposing transactions to your application like you normally would, right? To the smart contract. And your smart contract is emitting events, right? Information that you want to index or information that you normally would be making available to your front-end application. And then those events are processed by Graph Node, right? Using WebAssembly, right? There is essentially a module that runs, which we call a mapping. And that mapping goes through and processes the data and then stores the data in a database. In our case, with Graph Node, we store the data in Postgres, right? And then we expose the data through a GraphQL API through Graph Node. So Graph Node actually provides that API endpoint, and that is a decentralized API that is hosted on all of the indexers on the network. And so then your DApp just needs to query the API directly. So if we look at the technical like deep dive of the configuration file, this can look a little daunting at first, but let me kind of walk through it with you. The general configuration for a subgraph is that you have a manifest, which basically is kind of like the main configuration file, right? This is what tells the subgraph configuration what network you care about, what contract that you care about, right? What entities, right? How you want to actually store the data in the schema. So we call it a schema. It's, if anyone who is familiar with GraphQL, they're probably familiar with the schema.graphql model, where you actually define almost like tables of the data that you care about. And then we have a mappings TS, which again, this is written in assembly script. Assembly script is a subset of TypeScript, so it doesn't have all of the functionality of TypeScript, but it does the job for processing event data because we can import all of the types into the mapping, and then we can process that and then save that data on a configuration. So in this case, you actually deploy the manifest and the entity and the WASM to the decentralized network, right? And as this mapping CS is processing, it's storing the data into a Postgres database, and then Graph Node is exposing that with a GraphQL API, right? And so this is great for events. It's great for getting off-chain data. So like a good example would be like the Lens smart contract. Who here has a Lens profile? Anyone, any Lens users? So when you go onto Lens and you post something, right? You're interacting with a smart contract, but you're also interacting with IPFS, and you're also interacting with Arweave. And there's some stuff that happens on the back end. And so with subgraphs, you can actually index all of that data into one subgraph configuration using what's called file data sources. So there's a lot of flexibility for like events and, like I said before, like off-chain data on like IPFS or Arweave. And that's really useful for just, you know, basically storing all of your dApps information in one subgraph. So we look back at this mess of like all these different protocols, right, are making these transactions. And the idea is to make subgraphs, right? These are individual APIs that are exposed and available on the graph.com/explorer. And anyone, they're completely open APIs. Anyone can access them using the network, right? And so if you're building a dApp that wants to get information about an existing protocol, like maybe you're doing something with NFTs, you know, you might want to query the Foundation one and the Zora one. If you're doing something with DeFi, you might want to query Uniswap and Aave. And there are standardized subgraphs for that from Masari that kind of like bucket that stuff together. So the next method that I want to talk about is a new new method of indexing. So not that subgraphs aren't great. Subgraphs are really great if that's what you care about. If you care about events and you care about off-chain data like IPFS and Arweave, it's a really good solution. But if you have a protocol like Uniswap is a great example that has been deployed a long time, and there's lots of blocks that have passed with all the different transactions. And then we also take a look at the smart contract, and it's a factory. So what it's doing is actually creating key pairs every time someone adds a new token to it. You start to get a lot of data. You start to get a lot of data in the blocks. You start to get a long chain that you have to index if you want to go back in time and grab that data. And so Firehose and Substreams is a new idea of indexing data. So Streaming Fast is one of the core developers, and they've developed what's called Firehose and Substreams. So if we look back at the existing architecture, right, we have the JSON RPC method where we're doing the extraction there. We have the assembly script that's doing the transformation, and then we're loading that into Postgres, saving the data, and then exposing it with GraphQL. That's fine and dandy, and that's great. But JSON RPC is not the most efficient, as I mentioned before, for reading data, right? You do have to, first of all, you have to get this data in a linear fashion when you're doing a subgraph. So in the sense that if you want to go back to a certain block, like let's just say, I don't know, half of the time that Ethereum's been running and start indexing that data, a subgraph has to actually start at that point and then slowly process the data and read all those JSON RPC calls over time. So that can be a little daunting, right? Especially if it's a long-living application. We also have this thing where like the JSON RPC can be different on different blockchains. It could be different access on that. And then it's also hard to get archive data because you need to actually run a full archive node on the indexer, which can be rather large, and there's lots of data in there. And so, yeah, it can be slow, especially if you have a large application. So what Firehose aims to do, first of all, Firehose takes a completely different method. We replace the JSON RPC method with Firehose, which is essentially flat files. So you're still running a Ethereum node, but the Ethereum node is running a copy of Firehose, which is basically taking the blocks and storing the blocks in like raw data in flat files. So imagine each block is its own flat file. And this gives you access to all of the data that is available inside of the block. So all of the ordinals, the transactions, basically the full raw inputs, bytes in, bytes out, is available in those Firehose flat files. So we can think of it like this. The Firehose drops these files down. And then the idea is that we want to, instead of using a GraphQL schema to store the data, we use what's called protobufs. Google created this concept of protobufs, which is a standardized kind of like way to process like bytes. And so the concept with Firehose is we store that data, and the idea is to store that in a protobuf style manner. And this is battle tested. We actually use this on the hosted service for even now for a lot of the data that we index there, just to improve performance. And then for the transformation layer, right, we replace the assembly script method with Rust. So it's a Rust programming language that you need to use to do it. But the idea is that you are basically ingesting those flat files into Rust, and then you're able to stream out the data to wherever you want to. It uses this kind of method of modular architecture, which we'll show here in a second. So if we look compared, we can see the difference. JSON RPC versus Firehose flat files, assembly script versus substreams is written in Rust. So the beautiful thing here is the way that substreams are configured is you can actually, they're composable. So you can write a substream, and you can write a substream configuration that pulls in data for whatever you want. So let's just say you care about specifically Uniswap pairs, and you could write modules for pairs and pools, prices, and then you could also write another set of modules for sushi, for pairs and prices, and then you could also go out and get some data from the Chainlink prices, and then you can compile those in to another module that maybe does an average, right? Some kind of calculation on those. So very, very composable and reusable in that sense, because of this mapping out architecture. And then we can even go above that, right? Like maybe we have this substream configuration that is grabbing all of the average prices, but then we also have another substream, which is using the NFT sales from OpenSea to combine that into another substream that might have the USD volume per collection, right? Very, very composable and very powerful. And we also get the parallelizable aspects, right? So, like I said before with subgraphs, you do need to go back in time and you need to start at a start block and you need to let the indexer go through and index all that data. So for like Uniswap as an example, it takes about 2 months to index the Uniswap V3 contract, right? That's a long time. We can actually do that about 100 times faster with substreams. So it takes about less than 2 weeks to do. So yeah, again, we get access to the parallelizable because we can basically break up the work, right? We can say, all right, well, let's do the first 1 million blocks on one computer. Let's do the next 2 million blocks on another computer, and then combine those data sources together because we're able to see everything that's going on in those ordinals and in that raw data. And yeah, again, 100 times indexing speed performance. And so if we put it all together, people always ask me, like, why would I build on subgraphs? Why would I build on substreams? It really does depend on your exact use case. So if you want to utilize the JSON RPC, you just need event data, right? You might be using something like IPFS and Arweave. You can really get away with just using subgraphs, right? If you're using substreams, this is going to give you the access to the firehose, the flat files. Assembly script versus Rust is a huge one. Who here knows Rust? All right, I love it. So Rust is very difficult. I mean, I've been programming for 15 years or more. I can't even remember, how old am I? But my point is it's a complicated language, I think, for picking up, especially just because it's a little different than everything, unless you've been like a C programmer or a C++ programmer. So Rust can be a little challenging, right? And we have some people in the community working on something to make that a little easier for people. But for right now, you do need to kind of know Rust. And then we also have this different concept of data types. So we either care about, like, all right, do we want to store the data in entities in GraphQL, right, using a schema, or do we want to use a protobuf style thing where we can get the raw bytes and get the ordinals? And then again, linear versus parallelizable. If you have a really long living dApp with lots of data going through it, substreams might make more sense for you. But if not, subgraphs probably are fine. So the beginner to medium skill, when I say beginner, anyone can create a subgraph. It takes about 5 minutes to do. Like if you guys pulled up your computer and you went to the graph.com, you went to the studio, you could create a subgraph. You could point it at Bored Apes or CryptoPunks, and you could create a subgraph within seconds. It's very easy. But for substreams, you're going to need to know Rust, right? You're going to need to know Rust, and you're going to need to basically maybe change like some kind of example that's been written already to kind of fit your needs, which there are some available on the website, on the docs page. And then again, it just depends on how you want to store the data. So if you want to expose it through GraphQL, and that's fine for your application, you can just use subgraphs. But if you want to actually store the data in other places, like maybe you want to use ClickHouseDB, right? Or maybe you want to use flat files. You want to put it into flat files for something else you want to do, and you want to run your own daemon. There's lots of power there. You could even use a substream to go to a subgraph. So there are substream powered subgraphs as well. So you could parallelize the data and then also store it in a subgraph too. So there's lots of composability and more, I guess, advanced features that you get with substreams. So any of the builders here, I'd love to invite you guys to the Graph Builders office hours. So we do this every Thursday at 9 a.m. Pacific in the Graph Discord. So if you're not in the Graph Discord, I advise you to join. We usually post the events there. We would love to see you guys come in and learn about subgraphs and substreams. Please, if you want to ask me about it, anything, just let me know. I'm going to be here. Something else is just a quick shill. I recently made, who here would consider themselves a full stack developer? No, a few of you guys. Who here would like to learn full stack app development? Few of you. So this is a cool repo. It uses scaffoldETH, and it also teaches you about the graph. It teaches you how to write a subgraph. It's a cool little kind of thing you can do probably in just a day or two to go through and actually build a dApp. It also teaches you about Next.js, teaches you how to like do some hooks, and also how to deploy a subgraph as well. So it's going to be a cool resource if you guys are looking to learn. So yeah, thank you guys. This is my contact info, and I would love to just answer any questions you guys have. Yes.
I have a couple of questions. So I think I'm one of the only people that does those quests on Coinbase, and I delegated to the graph. Can you tell me what exactly I'm doing? I'm a non-technical person when I do that. And my second question is, so I'm a lawyer. So when you say you're organizing things, I love that. But I'm kind of trying to understand, like, what are the big sort of enterprise use cases for this organization of data? Like, it does make sense, but I'm like trying to envision, bigger picture.
Yeah, absolutely. Yeah, so if you're delegating on the network, you're basically taking like a stake of your GRT and you're applying it to be used on the network for some kind of compute, basically. So, you imagine you have the indexers, you're basically like putting your money in and you're getting a residual based on transactions that happen through the network. So it's kind of like a way to do like DeFi with the graph, I guess you would say. And then to answer your second question about like organized data, I mean, there's already lots of subgraphs. So Masari is one of the core developers, but they're also considered like the Bloomberg of crypto. So they've gone through and developed, a number of subgraphs for us. They had a huge grant to go through and create standardized subgraphs, and that's what powers a lot of their dashboards. So for something like Insights, that's very, very powerful. There are also subgraphs that keep track of like all of the tokens ever created or all of the NFTs ever deployed. So really anything you can think of in the crypto space, there's some subgraph that has been created for that. Yeah. Yeah, question back there? Oh, there's a mic right here.
Thank you. What is the freshness latency of this data in graph?
The latency?
Yeah, freshness latency.
Yeah, so I mean, it's definitely up for debate what the actual like latency for indexing the data is. You do need to consider like finalization of blocks, and there has to be this time where like maybe the data could be, not matching what the final. So it's kind of a hard question to answer, but I mean, it's fairly quick. Like you can do it in less than 100 milliseconds and expect that the data has been indexed. I would probably say even lower than that. I don't really have a number to give you, but it's fast. Yeah, another question? Yeah.
And who is feeding the data? Like anyone can feed the data using these subgraphs or?
So the indexers are actually feeding the data. So the indexers are basically running a node, right? And then the subgraph configuration is pulling from the full node that's running.
Got it. And these indexers are decentralized, I guess?
They are, correct.
And how many nodes?
So right now there's a little over, I mean, it kind of goes in waves, active anywhere from 200 to 400, but there's usually over 200. So I don't have an exact number as well, but you can look it up actually on the Graph website.
And what is the consensus protocol between them?
I mean, the consensus, so we actually have a gateway that we run that kind of controls the quality of service and controls the response rate to give you the fastest and reliable. But as far as like, if there's any consistencies in data that are not correct, you can essentially do a dispute. And so then we would basically slash that indexer for not behaving in a way that is, in a consensus way.
What are the criteria of being indexer?
Anyone can be an indexer. Yeah. So we do an indexer office hours that will kind of like teach you about setting up. There's also a lot of documentation. There's also the Launchpad, which is a Kubernetes solution to spin up an indexer stack. But yes, anyone can be an indexer. It's open community.
You mentioned that you are able to slash them, right? So there should be maybe some incentivize there, or?
That's a good question. I don't know. I think there's a way to look that up, but it's all based in the logic of how the receipts and the verification, the slashing is done. I don't have a lot of detail on that. I could tell you. I'm not the expert there, but yeah.
Thank you.
No problem. Another question here. Where is the output of substream stored? So the substreams uses a sync method, or a sync concept. So you can imagine you can make a sync for pretty much anything. The most common method is to sync out to like a database, or you might want to sync out to, you know, ClickHouse, which is another database, or to the graph. You could actually output to graph out, which goes to a subgraph. So there's a bunch listed on the Stream and Fast website on what you can, where you can put that data. But yeah, there's lots. Yeah, you could output to a Postgres as well. Yeah. Yeah, because subgraphs use the Postgres for storing the data and then expose it with GraphQL. Substreams have a sync out where you can put it to whatever you want, any database. There's I think it was like 12 or 13 that we support, or something like that. Yeah, so the question was, how do you make a decision on putting it in something like centralized versus using the decentralized network like Postgres, SQL, and GraphQL? I mean, that's up to you, right? We definitely have people, I should say, dApps that want to store that data somewhere and keep it for a reason, and then they want to expose it in their front end. So, you know, Substreams is a great thing for that because you can still process the data and then store it in whatever database you want. Maybe you just want to back up. I don't know. There could be a lot of reasons why you do that. I think, you know, from a ethos standpoint and like Web3 standpoint, we want to be decentralized, right? So, you know, eventually we're going to offer data services. So we're working on data services for the graph. I didn't really talk much about that, but one of those would be Postgres SQL, basically a SQL endpoint for you, where you could expose the data in a decentralized way through SQL. There's a really good core monthly dev call today about that. You can rewatch it on YouTube. So yeah, I mean, either way, I think the idea is to keep stuff decentralized. That's what I believe in. But obviously, Substreams give you that power to centralize your data if you want to. I'm not sure how much time I have. A couple minutes. I got a couple more questions. I know I thought I saw another hand somewhere. Oh, here we go. Well, there could be an existing subgraph, right? So the question was, like, if you're a subgraph developer, you need to know exactly where to look. So is that what your question is? Like what contract, what network you care about? Yeah. So, I mean, usually you create, like for a subgraph, you create it based on like this contract, this network, right? But there might already be an existing subgraph you could use. Like, you know, like if you want the CryptoPunks, there's like 3 or 4 different subgraphs that have already been written, and you could go to the Explorer and find one and use it. Or you could use the Masari ones for like DeFi or whatever you want. But yeah, if you're a developer and you want to create one, I mean, usually you're building it for a dApp that you're maintaining. You know, you've written the events. You know, you're storing the data somewhere in IPFS, and you want to build that smart contract. And yeah, you point it at that. Yeah. One more question. One more.
So, if there is a new category of data to index, like from Lens has Momoka that they launched. It's not quite decentralized yet, but if we want to index that data or forecast the data or so on and so forth, is there already an existing one? If there isn't one, how do we approach, you know, have that be opened up and run one our own and so on and so forth?
Yes. So I think the question is related to if like there's not support for a specific network or a specific protocol at the moment. I mean, if it's a chain, you know, we are trying to work with like popular chains to integrate onto the system. Like as you saw that one slide. If it's an app like a dApp, you know, we also try to work with them to get their data in there. If it's some other protocol like that, you know, other than IPFS and Arweave, you know, same thing. We would just have to like onboard them. Eventually, we want to make that more permissionless and open, so that anyone can start adding data options to the blockchain. But right now, it is somewhat gated, just because we you know, have to control that in some ways. But we do want to decentralize that aspect. So if there's someone out there that, you know, needs a chain, reach out to us. Or if there's someone out there that needs a new protocol, reach out to us, and we can try to evaluate it. So. Great. Yeah, thank you so much. Thank you.
All right, thank you. Next up, we have DeFi security patterns here, and then we've got gas optimization in the boardroom. So DeFi security here, gas optimization in the boardroom. And then the break in half an hour. And then the roundtables.
Thank you. Thank you. Hello. Yeah, please. Please go ahead. Oh, it works. Thank you. Um, why? What? What happened? Hello everyone. Nice to meet you here. And today I will give the talk Define Security Pattern. I'm Hongbo from Rima Labs, and our Rima Labs is proposing a new security practice for DeFi and blockchain ecosystem. Let me introduce our team a little bit. We are the top tier security researchers with proven records such as academic papers and the discovery of previously unknown vulnerabilities. But the most critical part is that we are viewing the blockchain ecosystem from hacker-like style. Yeah. Okay, let's step into the main line. As we all know, today's DeFi is vulnerable. Let's say since 2020, more than $10 billion have been hacked, and those hack events are going on again and again. Naturally, people will ask the question that, what's going wrong? Throughout the history of DeFi, there have been many attack patterns. For example, let's say integer overflow, reentrancy, and flash loan attacks. Compared with older ones, recently price manipulation, precision loss, sleeper arbitrage, and router approval attacks have been known by the community. The critical insight is that more and more complex attack strategies are employed by hackers. Nowadays, the hackers are not satisfied with just focusing on easy patterns such as integer overflow and reentrancy. Instead, they are looking for deeply logical flows in the DeFi protocols, and such as to be the core of the exploit of towards those protocols, such as price manipulation and position loss. However, current security tools such as Slither from 12bits could only detect the vulnerabilities based on easy patterns. But you know that hackers hold the most powerful tools and keep creating new types of attacks. So current security tools are far from protecting the DeFi community. Here are some key attack statistics based on data points from DeFi Hack Labs. Firstly, over a half of exploited protocols had been audited by professional auditors. Although those auditors put most effort on securing those protocols, just one missed vulnerabilities will lead to a huge loss. Thus, we need more protections beyond auditing. Secondly, most of hacks happen within, let's say, 3 transactions. The first one should always be the deployment of attack contract, and the second and third one were triggering were involved for triggering the bug and profiting from it. Thus, nowadays those attacks are almost unpredictable, and there's no time left for the reaction. Thirdly, it's the most shocking event is that it took around 6 days before the hack unrolling was known by the dev team and the community. So it suggests that hotfix from the dev team is not always available. Finally, around half of hacks shared almost the same strategies as the previous known attacks. Thus, this case suggests that the patches need to be distributed within the community. I hope those data could give you an overview about our defined security practice today. From a higher level, actually today's defined security practice is mostly focusing on the auditing. However, the dev teams don't have strong tools to keep the protocol safe continuously after the deployment. The root cause is that, let's say here is a missing piece after the deployment. As we all know that there's no silver bullet during the auditing phase, and the dev team always don't know when and how the attacks will happen. And eventually when the hack event is reported to the dev team, it is always too late. And in the general, the patches for folks will not be shared within the community. That's why our RIMA labs are proposing a new security layer. It should be a proactive, real-time, systematical security solution across all life cycle for DeFi's. The new security layer should take charge of the entire life cycles of DeFi's and blockchains. According to the time the defense get involved, we divide the life cycle after the deployment into three phases and name 3 strategies accordingly. The first is that after the deployment and any potential attacks, we have the proactive defense. And if any attacks escape from the first defense, we still have the chance to prevent them in real time. And finally, for every discovered attack and any potential patches, we should, let's say, distribute the information into the whole community in a stable way to make sure any folks are safe. That's what we call patch defense. Let me go through the detail a bit more. So in the pre-attack phase, we need a vulnerability scanner to scan whether there is vulnerability in the protocols on the chain, and if any vulnerability is identified, the exploit synthesizer will give a concrete exploit to prove that it's a real vulnerability, and we do the Y-hack report to the dev team to drive them to fix the problem. And for the during attack phase, we also have 2 major subcomponents. The first one is attack detector, just to decide whether a transaction is malicious or not. And when once a transaction is recognized as malicious, we will do the attack mitigator. We will employ the attack mitigator to prevent the attack in real time. And after those 2 phases, during the post-attack phase, we will distribute our patch, and we will update our attacker strategy to the first 2 phases. And I think so. That's how we protect the blockchain transaction by transaction, block by block, into the entire life cycle. Beyond defines, the security layer could protect, let's say, all entities on the blockchain. Let's say safeguarding the blockchain for billions, both dollars and users. Security layer is actually a universal solution for the blockchain system, supported by, let's say, 4 or more analysis components. We will analyze transactions, address clusters, protocols, and past attack strategies. Supported by them, the security layer could be expanded to a larger scope, including user-side protection and hacker-side protection. I mean, preventing hackers, and the protocols, the protocol level protection and blockchain level protection. I will give more detailed use case later. Okay, so for the use cases in layer 2 blockchains, first we could do the chain-specific alerts, such as verify layer 2 state assertion made on the layer 1, and we could do the malicious transaction alert and mitigation from the level of layer 2 to secure all protocols on that layer 2. And we could also do advanced attack mitigation, like it's a 100% mitigation if we have the access to the memory pool of layer 2, because we could always front run the attack from hackers and prevent them. From the defined protocol levels, as we mentioned before, we could do on-chain exploit generator. We could do the attack mitigation if we have the access to the protocol. And we could do the emergent funds preservation if we have the permission to pause the protocol if the dev team trusts us. And for the end users side, we could do the security alerts by the mocking of transactions to tell users that, oh, here is a malicious transaction you made, and please stop it. Another potential protection for users is that we could do the permissionless proactive defense to just prevent the transaction and keep the funds safe for the users. If we if the permission is given by the user, we could also withdraw the funds from the router to prevent the permission-related attacks, such as router approval attack. As we all know that about 4 weeks ago, the Unibolt router was being hacked, and many users lost their fund because they just approved the maximum uint to the Unibolt router. We are not just provide the vision, but we are also working hard to convert it into validation. Here are some showcases about our progress and real-world examples. First, our prototype of security layer has the real-time mitigation of hacks. We could stop during the simulation, we could stop famous attacks from the past, such as Saddle Finance, such as Inverse Finance, and such as Yelm Finance. All of, let's say, most of those protocols are audited by the top-tier auditing security companies, but they still miss, let's say, 1 or 2 vulnerabilities to make the attacks possible. From the protocol level, we could generate the exploits for historical attacks within dozens of seconds. But the domain is limited to that. There is a flow in their in the protocol's financial model. Compared with the state-of-art tools, we are more efficient and more fast. But just this domain, let's say the defined domain. Fortunately, we could generate previously unknown exploits as known as zero-day bugs. Here is an example for the safe haven protocols, and we successfully saved them from the potential exploit by generating the exploit, submit it to the dev team, and the dev team had confirmed its correctness. And now safe haven is really safe. And finally, for the protection of users, our prototype have saved the victims in the some of victims in the Uniboat hack events. We constructed a counter attack to mitigate the exploit and secure 57 kinds of tokens for 68 affected users. And eventually, our vision is to eliminate more than 90% of hack events in the DeFi domain, and the proactive defense should save about 30%, and the real-time defense should save about 60%. To summarize, we are supposed to build a security layer to convince the billions of users that the blockchain ecosystem is not a toy, is not a playground, but it's a safe place to earn the profits. And thank you for today. And our vision is that as Rima Labs, we are crafting a secure and hyperlinked blockchain future. Thanks. Any question? I think it's, oh. This page, yeah. Yeah. Yeah, I use the open source version of ITY Force. I think ITY Force is an amazing tool, but just for this domain, we perform better. Yeah. Please go ahead.
In your slide, you just mentioned you can stop some of the smart contracts. You stop the trade, the transaction. So you mentioned that if the project team can trust you, but would that kind of concerns the other people? I don't know. Like if you can stop some of the protocols, would that like a sensor resistance kind of concerns? Because if the project can be or resident on the layer you built, or do you have like a control power for the transactions through you?
I think we have two kinds of services. Like if you trust us, we could prevent more attacks for you. But if you don't trust us, we just do normally, which we could not do the service for you, but we could also do the service like so if we are very confident about that this transaction is a malicious one, we could prevent them if you allow us to do so. If not, we will do nothing.
The other question is when you like a this is kind of all like a predefined of the like those malicious behavior, right? For example, if a sandwich attack, you can easily identify.
Yeah, because from a hacker's aspect, the pattern of those malicious behaviors are very similar. Like you could summarize them as the sandwich attack, and if we have the permission from layer 2, we could prevent all of sandwich attacks on that layer 2, because we have the access we have the access to their memory pool, and we could decide the order of committed transactions. So that's how we prevent sandwich attacks.
Okay, thank you.
I think for so currently it's the overall architecture, and we are working on implement all of those analysis components. But yeah, I think half of them have been implemented, and we are implementing the remaining analysis components. I think that's a good question. I think I think currently we are not we are we are not expecting it should the security layer to be totally decentralized, but we are happy to discuss whether it should be decentralized or not. Like perhaps hackers will provide some malicious strategies to taint the attack analysis space. So that's the concern from our side. Yeah, but we are open to discuss whether it should be decentralized or not. Oh, okay. And then thanks for your listening.
So we're going to be on break, and roundtable discussions are going to resume at 3:15. Are other people just connecting a laptop? Is that easier? If you want, you could do that.
Hey everybody, we'll be starting in about a couple minutes here. Just bear with us. Thanks. So we have bridging patterns happening in the boardroom, and then on-chain liquidity, we'll be talking here with McDavid Stoddard. Coming up in a couple minutes.
Hello, hello. First off, real quick, so are there any product people in the room? Product managers, product marketers, armchair, Twitter, PMs? A few, okay. Next question. So has anyone ever LP'd on Uniswap v3 before? Yeah, okay, not bad. A couple people. Cool, so yeah, today I'm gonna give kind of a brief overview of liquidity patterns and yield from Aperture's vantage point over the past 2 years. The talk's going to be fairly product oriented versus some of the more dev deep dives we've been having this afternoon. And I'm also going to talk about some macro themes that are affecting one very large DeFi protocol that's kind of in search of market domination at the moment. But yeah, basically where we're kind of heading, I'll go ahead and kind of give you away the thesis, is that on-chain yield is trending down into what I think is a much more reasonable end state. And at the same time, you have on-chain liquidity gearing up to eventually, I think, flip and overtake off-chain or so-called centralized liquidity. But without further ado, let's jump in. So quick intro, I'm sort of a generalist at Aperture Finance. You can think of me as like the head of product market fit. And I've been there for 2 years. I was previously a crypto lead at Smart News, which is a large news app. If there are any Japanese people here, you've probably heard of it. Otherwise, probably not. I've done over 100 interviews with UniV3 LPs this year alone. This has been a space we're super focused on. We've launched a rebalancer, or like some tools for UniV3. We've done over 100 million in rebalancing since July. And some of my favorite failures are we turned down investment from Binance and we accepted money from Do Kwon. So Yeah, so yield patterns. This is a tale of 3 products that we've had at Aperture Finance. 2 of them were failures, both for different reasons, and then we have one now that's so far so good. So starting off here, this was a vault we had launched on Terra Classic almost 2 years ago. And real quick, before I'll kind of jump in and talk about some of the crazy things that were going on with this vault, but real quick, can anyone in the room point out which of these 1, 2, 3, 4, 5 numbers is the so-called real yield? You can just shout it out if anyone has an idea. The top is Anchor Earn. The next thing is a farm token from Mirror. The next thing is a farm token from Spectrum Finance. And then again, another farm token from Mirror. And then there at the bottom, 1.45%, TerraSwap trade APR. That's the real yield. Everything else is totally unsustainable emissions and like Ponzi-nomics. And at the time, 36% APR wasn't even that high or crazy. This was still the era where there was triple-digit yields on lots of platforms. But the thing about this strategy that helped it get to 120 million of TVL before Terra eventually depegged was that it was very scalable, and it was a very well-known strategy that was building on the market success of Anchor Earn. The strategy was basically greedy Anchor Earn. And the strategy was basically called the Delta Neutral Anchor Mirror strategy. And it was incredibly technically difficult to automate this in a vault. There's a lot of steps that were involved in this, but ultimately doing this enabled people to like get this yield without having to like sit at their computer all day. So we had everyone from small retail users on Terra Classic depositing into this vault all the way up to Celsius. The DeFi team at Celsius had put over $10 million of UST into this vault at one point in time. I think the presentation is being kind of weird, but I think even at the time, Do Kwon, I mean, this is sort of a cheeky tweet, but I think even, looking back on this, it's like, wow, did he at the time even kind of think some of this stuff he was doing was sort of ridiculous? Every day we stray further from God. So yeah, that was our first vault. Had very good, at the time, product market fit, but totally unsustainable. And this was the business Aperture was in at the time. We were making vaults, we were selling yield. We were using our like dev capabilities to package these things into vaults. And so Terra depegs, and we kind of go on a soul searching journey. And here, let me, do you know what's causing this to, oh. That's better. But yeah, so we go on a soul searching journey, and we haven't yet entirely learned our lesson. So we launched yet another one-click vault. So you, as the user, your experience is you see a yield number, you're like, yeah, I like that. And you kind of ape into it based on an APY that's being displayed. Still, you can see on the right-hand side, the yields are still kind of ridiculous. If you would expect to actually get that over the span of a year, it's kind of crazy if you think you could actually get risk-free 60%. The first thing you will notice here is that we're starting to realize that maybe these things aren't so sustainable, because now we're calling it crab market leverage farming, because we're at least acknowledging that underlying this strategy, so the strategy where this works is it's leveraged yield farming. You're levering up to provide liquidity on the Avalanche ecosystem. But the way it works is, as price moves, you have to rebalance. And then you're locking in permanent loss when that happens. And so if there's a lot of volatility, you're rebalancing in one direction as it goes down, you rebalance it as it comes back up, and you've now just had a lot of your principal get eaten into. So we call it a crab market because we're trying to imply this thing will not work in a high volatility environment. And lo and behold, the actual average 3-month return was 0.3%. So this thing didn't work. But onwards and upwards. So at this point in time, we kind of start to realize we should get out of the vault business, and we should sort of open up the underlying technology that was empowering these vaults and let the users decide. You bring your own alpha, you have your own strategy. We're here to help you automate it. And so we kind of ended up finding a home on Uniswap v3. And this led to the product suite we have now, which is a suite of tooling solutions for LPs on Uniswap v3, with the biggest solution being rebalancing. If anyone's familiar with Uni v3, the process of moving your liquidity requires doing 3 transactions, remove the liquidity, do a swap, re-add the liquidity. Then you also have to solve a math problem along the way as well. So we kind of simplify that for people into one step. So we call this our structured product retirement. We're out of the vault business. We're now into the tooling game. So yeah, in summary, what you saw in these 3 products was really kind of like an overview of where I think a lot of DeFi yield has moved over the past 2 years. At the end of 2021, the beginning of 2022, this is really the like golden age of farm tokens, emissions, Ponzi-nomics. There was also an abundance of alpha, meaning these strategies that people were concocting were everywhere. There was these arbitrage opportunities that were huge, that would last for quite a long time, and there was delta neutral strategies that had really high carrying capacity that were proliferating across YouTube and across crypto Twitter. Everything was very much public and out in the open. This is during our kind of Terra phase when I said we hit that really high TVL number. Coming into the second half of 2022, though, basically the industry, I feel like we're starting to do some soul searching after the hangover from the Terra collapse, which really kind of marks the end of the golden age of Ponzi-nomics. And about this time, the real yield narrative emerges. And at this time, I think what was stealing a lot of the thunder was GMX in the second half of 2022. That was getting quite popular, and they were famous for paying out the LPs in ETH if you're on Arbitrum, or AVAX if you're on the Avalanche network. And still at this time, though, I don't think Uniswap v3 was getting a lot of the mind share within the industry. But also at this point, I would say alpha decay is kind of setting in. There's not a lot of yield strategies, and this for us was really evident in our conversations with institutional, like on-chain hedge fund types, who were kind of just like taking a step back from DeFi. They weren't doing as much. And this, if you look at DeFi Llama and just look at stable coin volume over this time period, it kind of syncs up with this thesis as well. This is the time when we had this sort of failed second vault on Avalanche for Aperture. Anyways, you get to 2023. And then I would say there's kind of still some light kind of emissions going on in the industry, and yeah, just tap the. Yeah, so airdrop farming versus sustainability. What I'm talking about here is there's a little bit of emissions still going on that are a necessary evil to a certain extent, because the number of real users who are not operating based on incentives in the DeFi world right now is very, very small. We hope and expect in the future that there will be lots of new users, institutions, retail users coming on chain that will bolster that number. But as it stands right now, a lot of the money on chain is obviously airdrop farming. So you kind of have to play the game a little bit right now, but I think the protocols are starting to grow up and be a bit smarter about how we go about doing that. And obviously, on the alpha side, things are a lot more competitive than they were 2 years ago. And this obviously, at this point in time, Aperture, we've gotten out of the structured product game and we're fully in the tooling business. So yeah, in summary, like super basic breakdown, very high risk, high reward in the golden era, lots of alpha. Second half of 2022, risk is still there, but alpha is gone. It's kind of like the bottom of the yield market in some ways. But as we get into 2023, risk is starting to trend down, yields are coming down. Alpha is still quite not there, but I'm hoping in 2024 that we will have a slightly less risky environment, meaning there's sustainable lower yields for the DeFi space. Okay, so kind of pivoting here. So that's what was going on with Aperture during this 2-year window. Now, I also want to talk about another protocol that's quite important to this space, Uniswap. So help me out with the, yeah. So brief, I think when I originally was writing these slides, I had no idea how technical the audience was going to be. So I suspect most people have a pretty good understanding of the history of Uniswap. So I won't spend too much time on this slide, but basically V1, right, constant product, ETH pairs only. We get into V2, it's still constant product, all pairs. As with V1, everything's fungible. And then V3 is where you have the big upgrade. That's the introduction of concentrated liquidity. We're no longer 0 to infinity for everyone providing liquidity. You as the LP decide the range that you want to provide liquidity in. This is so-called the more capital efficient approach. This is also non-fungible now. You're receiving an NFT as your receipt token, not a fungible ERC20. And all of these, V1, V2, and V3, off-chain, during this like whole arc for Uniswap, off-chain liquidity is still the most important space for price discovery on big assets. Binance is still where the majority of the trading volume is happening. But what's possibly happening with V4, and I'll dive into V4 a little bit more, but V4 is basically introducing hooks. That's the main upgrade here, and we'll talk about hooks in a second. But potentially what I think, and I'm hoping comes out of V4, is that we eventually have a liquidity flippening that happens where the majority of liquidity ends up on chain because we've now solved enough of the problems that we're kind of blocking that from happening in the past. So yeah, Uniswap V4. This is really like the App Store moment for Uniswap. And so if you're like a third-party protocol, what this means is you can spend a lot more time innovating on unique DEX designs. You don't have to spend as much time bootstrapping liquidity or bootstrapping swappers because you're going to be able to sit and enjoy the like Uniswap order flow. So this is quite similar to the App Store launching back in 2008. And now we're going to have an equivalent setup on Uniswap where there are lots of mini DEXs sitting on top of the platform that have their own unique spin on how to solve various problems in the liquidity space or certain use cases that you can unlock. And how are they doing this? So they're doing this through this thing called hooks. So if you have this is very, very technical-ish, kind of hand-wavy primer on how hooks work. But so in a typical V3 block, you have 3 transactions. Someone adds liquidity, someone does a swap, someone removes liquidity. Pretty straightforward, nothing interesting going on here. With hooks, what you have now is the app, the so-called hook developer, these third-party protocols. In this case, of this block that had 3 transactions, there's 4 points where they can do something unique. At the start of the block, before anything's happened, after the first transaction, after the next transaction, and at the end of the block. And so in practice, can you help me out with the scroll? In practice, it's basically like there's certain logic that will be checked for before any transactions happen. So you can kind of look at this flow chart here and get a sense of what that looks like. But let's talk about what exactly here is possible. So these are some kind of vanilla ideas that the Uniswap Labs team put forward. So one thing is a truncated oracle. This basically would sort of like blunt the price impact of a really large trade happening through a pool. And why would you want this? So let's say you have like a lending protocol that's looking at the pricing in this pool to determine collateral ratios. If someone comes in and does a huge trade and it kind of like fucks up the pricing in the pool for a second, someone could get liquidated. The idea with the truncated oracle is that you could blunt the impact of that happening. Something that's possible with hooks. Obviously, limit orders. There's multiple ways you can do a limit order with V4 hooks or within Uniswap X, which is also kind of another piece of this equation. The time-weighted average market maker. This is basically a way to do really large orders on chain. At Aperture, we've spoken to a number of institutions who have been looking for solutions to like do really large orders on chain and not have to go through some kind of centralized off-chain entity that can help facilitate those trades. So there's a way to piecemeal up chunk up these trades in a liquidity pool so there's not a lot of price impact at once. There's also some kind of crazier ideas. So you can obviously have KYC pools based on this hook idea. You could have, I even saw, so there's a KYC pool. Someone else in the same repo of hook ideas put an anti-KYC pool where if you have KYC, you're not allowed to swap in it. And then some things that address the problems LPs have in Uniswap. So a volatility fee hook. This basically would allow like a volatility oracle to be fed into the liquidity pool. And as volatility kicks up, you can increase the fees to further compensate LPs for the risk that they're taking in a period of high volatility. You could even do something like New York trading hours. The idea, I think, behind this would be that one day you could have, equities on chain in a V4 pool. So yeah, thank you. This is kind of a quick overview of some of the stuff we've seen at Aperture in our kind of product market fit journey with respects to the kind of state of yield in the market and kind of how we wound up on Uniswap and sort of what I think things are going with Uniswap in the future, which is quite exciting for them. Yep, thank you. Yeah. Yeah, great question. This is definitely something that was top of mind from the product side at Aperture. So initially, when they were kind of rumoring about V4 being announced, so V4 was announced like in I think June or July. It's when we, the public finally got to see what was under the hood. Our worry before that, like so around May, our biggest fear was that all the tools we were building, Uniswap was going to natively integrate those into V4. That was like if you were talking to LPs like we were, you're like, no shit, they would add these tools in. That's such an obvious idea. Like, I hope they don't, wipe out our product. But what they ended up doing was kind of going in a completely opposite direction. They're like, no, actually, we're taking a like even further step back from the like LP user experience, and we're going to like turn this over to the third-party protocols to like set this up, and everyone can kind of have their own crack at what's the best LP experience. So we were in general, we're pretty happy. We knew we would have to update something for V4. We were just hoping they wouldn't have to like start from square one. Yeah, they've cleared the way for third parties like Aperture to like continue to build on top of Uniswap and have reasonable assurance that that's going to be a fruitful endeavor for them. Any other questions? V4 is not launched yet. There's a good repository. Some of the screenshots I was pulling. There's a good repository of like I guess you'd call them like proof of concept hook ideas, but I don't know if any of them are even audited or like could be launched on production. So we're expecting V4 to launch sometime the first half of 2024, but we don't know exactly when. Cool. Are you in Taiki's Discord? Okay. So vaults can mean a lot of things. So in Aperture's, from our perspective, what we mean by vaults are like, it's a predefined liquidity providing strategy, in this case on Uni V3, that it's kind of like this. It's like, when the price of Ether goes down 10%, then rebalance me to 50-50 around the spot price and just like execute that logic in perpetuity. Those kind of vaults we think are not a great idea unless you're like a very, very, very sophisticated market maker and you design it yourself and you kind of have a thesis. Some of these other vaults, like the thing that like the Maker and Cantor stuff, that's quite different. I think there's still a place for those sorts of ideas to exist in the space, but we just kind of want to take a step back from. Basically, what we're saying is there's no set logic that can have a profitable LPing strategy on a concentrated liquidity DEX over time. You have to be flexible, and there almost always has to be some kind of like human judgment involved to keep those positions profitable over time. And so that's why we're just giving people the tools to do that on their own and not trying to package it into a product. All right, well, thank you. I'll turn the mic over.
Thank you. All right, guys. Up next in the boardroom, we have, let's see here, web fuzzing patterns with Rai Su from Fuzzland. And then in here, I'll be giving a talk on rudimentary DeFi patterns through the lens of the ERC 4626 standard. I'll be starting in like 2 or 3 minutes. Just bear with me. Thanks, guys. Okay. How's it going, everybody? Hope everybody's enjoying BuildETH Patterns so far. My lecture is going to be relatively brief, and then we can take questions after that, and feel free to ask questions along the way if you'd like. So my name is Connor Gallagher. I work and build stuff at cookbook.dev. We're a smart contract registry and specialize in dev tooling. And today I'm going to talk about rudimentary DeFi patterns, especially what I call the underlying token pattern. And I'm going to touch on hooks as well through the lens of the ERC 4626 standard. All right, so we're going to go over what a pattern is. And then I'll kind of briefly review what the ERC 4626 standard is as well, some of the ins and outs. And then we'll talk about this underlying token pattern that you see throughout DeFi and the hook pattern that you see in both the standard and in several places in DeFi lately. So what is a pattern? As far as software is concerned, design patterns are standardized, customizable solutions that address frequent challenges in software design and help us as developers kind of solve problems on a business logic level and execute them in a way that keeps our communities working synergistically. A brief overview of the ERC 4626 standard. It was authored by Joey Santoro, Transmission 11, and Jet and Senor Dago, all guys from Tribe DAO, mainly Faye and Rari protocols. Vaults at the time, and still do, offer multiple services, including providing fixed yield on tokens and pooling tokens to issue yield-bearing tokens. So essentially what that means is you are going to put an underlying token into a smart contract in hopes to accrue value on a yield-bearing opportunity that vault or contract is attached to. The issue at the time was a lack of standardization, and it led to many diverse implementations at the time, and it really created kind of like we see time and time again in this industry, a lot of issues as far as things working well together. And basically, the ERC 46, the ERC 4626 was an interface that allowed depositing and withdrawing of these tokens from any kind of strategy that handles a single token. So let's kind of get into how they do that. So one of the core functions is the deposit function. This deposit function, it takes in a data type of unsigned integer of 256 bits called assets and an address called a receiver. This deposits assets or this underlying token, typically the ERC and ERC20 token, most commonly wrapped ETH, especially earlier on, and issues corresponding shares to the receiver, usually pro rata or 1-for-1. Withdraw has a data type of uint256 as well, two addresses, the receiver and the owner, and this withdraws assets from the vault, redeems the shares from the owner and burns them and sends the assets back to the receiver. This is useful when the user knows exactly how much of the underlying asset they want to retrieve. The contract then calculates the amount of vault shares to burn in exchange for the withdrawn assets. So basically, when you withdraw the vault tokens that were minted upon your deposit, you essentially return them to the vault contract. Those get burnt, and then the value that the underlying asset either accrued or lost during the period of time that you had your deposited your underlying asset, and whatever the strategies accrued attached to that vault, plus or minus, is what you would get in return. And then redeem is essentially the same thing, but from the perspective of using shares as the operative UN instead of assets, right? So instead of the underlying ERC20 token, the amount you're giving the amount of shares. So it really depends on the context and what exactly you need in that certain situation. So the preview deposit and preview withdraw, these are both read view functions, and it essentially provides a preview before each of these actions. And they're mostly used for, like, obviously when you have fees involved with your vault, which of course everybody does, but it allows your user to understand what exactly after all of the fees and anything else, what their deposit's going to look like, how much will be deposited into the vault as an underlying asset, and how much they will get back when they withdraw. Basis points. So the percentage of the total assets you are interested in expressed in basis points. This is usually how people, I mean, just in general in finance, this is how you're going to calculate essentially the total assets in the vault and how much your shares are, how much shares you're going to get in return. So let's talk about the underlying token pattern, which we kind of just like, you got a gist of, right, with all the functionality, the core functionality I explained about through the ERC 4626 standard, which is why I chose it, because it's kind of like very clear, right, like how that works. So this pattern starts with an EOA, or a smart contract that wants to use a single token as an underlying asset. So this could be anything from wrapped ETH to DAI, whatever is chosen at the time of the vault's deploy. The underlying asset address is passed through the constructor traditionally. So what that means is, like, we're going to be using this address to interface with the token, get approvals mainly, permissions for both to spend this depositor's DAI through whatever strategy is chosen by the vault manager. And the underlying asset address is passed through the constructor for both gas optimization reasons. Usually you keep it as an immutable variable at the top of the contract and pass it through the constructor, which makes it cheaper to reference gas-wise. And as well as, well, that's honestly the main reason. Once the vault is deployed, its address is given the appropriate approvals via the underlying tokens approval function. So yeah, that's pretty straightforward. One thing that might not be as straightforward if you haven't worked with vaults is there's also a set of approvals that happens for the user who acquires the shares once they've deposited their underlying asset and are returned the vault token and or shares, quote unquote. They also are given approval to spend, those shares and or trade them, depending on the situation. The vault then gives approval to the depositor for the vault token or share. Okay, so basically what I just said. Okay. So once again, we're going deeper into the deposit. So whether an EOA or contract, when the deposit function is called, the arguments, assets, and receiver are used to mint a vault token pro rata, or for each underlying token or assets that has been deposited, and send them to the depositor, which we went over. So this is kind of an overview of what we're talking about. This is usually where fees are injected, as we spoke about, and the usage of preview functions are called. The after deposit hooks, so this is where we kind of get into hooks. Now, to kind of like just talk a little bit about hooks before I get into this, like, and it was covered a little bit before in the talk before, but with hooks, there's kind of like a life cycle of transactions that happen inside of these contracts. And, like with V4, you have before deposit, after deposit, or excuse me, before modify position, after modify position, before swap, after swap, before donate, after donate. There's one more with before and after that is escaping me right now. But there's 8 all in all in V4 Uniswap. And the ERC 4626 standard kind of uses this as well. This is how they inject the ability to take these deposits that have been made in this vault and then transfer them to a yield-bearing strategy, right? So the after deposit hook essentially would be called literally inside the deposit function. And you would put inside of that hook essentially, most likely, a call to either a middle contract that passes off the funds to a yield-bearing strategy. It would also probably have some sort of float logic. Float logic is very similar to what banks do with your money when you deposit money into a bank. It essentially decides how much is going to stay in there in the vault and how much they're going to bring out to a yield-bearing strategy on your behalf. And so this hook is just, like I said, all hooks are just logic that's executed during a life cycle of a contract. And in this scenario, it's after the deposit. Whoa, okay. And then withdraw and redeem. So this touches on the before withdraw hook, which usually checks the float amount in the vault. And if the vault's total underlying assets are greater than the amount being withdrawn plus the float minimum. So usually you define like a constant, like a float minimum, like an absolute value that the vault cannot go under. And from there, you would essentially then the withdrawal is executed. Otherwise, this hook will call a harvest function to extract funds from a yield-bearing strategy to bring the total of underlying assets up to its appropriate amount. So what that essentially means is this hook will check, hey, is there enough in the vault to give this person the assets they've accrued plus or minus what they deposited? If yes, then great. If no, then we need to go harvest from a yield-bearing strategy on their behalf, fill the vault up with the amount they're taking out, plus whatever float needs to be provisioned, and that's that. And when an actor wants to withdraw the underlying value accrued, the withdraw or redeem function is called based on the actor's use case / context, which we covered a little bit before. And just in review, that essentially means with withdraw, this is useful when they're trying to retrieve based upon a number being the underlying asset. So in this case, let's say our vault, the underlying asset is die. We'd say, oh, I want 5 die back from the vault, or 5,000 die, or however you want to look at it. And then the contract then calculates the amount of vault shares to burn in exchange for the withdrawn assets. So yeah, the last thing that happens is it takes back your shares, it burns them, and then it exchanges the withdrawn assets. And then, like I said, redeem is kind of the other side of that coin. It's instead of trying to withdraw by the actual underlying asset, you are going to withdraw by the vault token, the amount of vault token and or shares that you have. Finally, this, and we just went over this. Finally, the actor shares are burnt and the value of the underlying asset deposited plus or minus the yield accrued by attached strategies are returned to the actor, completing our pattern. Excuse my typo. So closing thoughts. We see the underlying token pattern a lot in the DeFi space, whether it's vault protocols like Yearn, Beefy, and Smollier, or index liquidity pools like Uniswap, SushiSwap. The ERC 4626 is an attempt at standardizing this pattern, among others like the hook pattern that is used in the standard to apply yield-bearing strategy, logic, and internal accounting. So yeah, that's basically the idea and the whole pattern altogether. Thanks, guys. Yeah.
I know that's most of the use cases today, but do you see some of these yield-bearing strategies be applied to like Lido or like staking yield? Right? Is that very constant in some way?
Yeah, there's actually, and excuse me because I can't remember the standard's name. It's relatively new. I believe it came out in October or was proposed in October. The same author, Joey Santoro, he is actually building an extension to the ERC 4626 for LSDs. So yeah, so specifically for liquid staking derivatives. So to answer your question, absolutely, I believe so. I think it has to be approved. Still, I believe it's an EIP, not an ERC. But yeah, I think this construct is kind of like robust enough and general enough. I think that's why it's kind of elegant, especially even down to like the redeem and withdraw, or with the difference between redeem and withdraw. There's just like very like elegant nuances throughout the standard that make it very easy to work with. Anybody else? All righty. Well, thank you guys. I really appreciate it. I hope you guys enjoy the rest of BuildETH, and I'll announce the next speaker in about 5 minutes. So get up, stretch. Thank you. Cheers. All right, guys. Right now we have Elliot Friedman in the boardroom talking about Foundry patterns for standardization and security. And here we have Rulan Chai, Rollin, sorry, talking about account abstraction patterns.
Thanks, Connor. Thanks for having me. Yeah, it's honor to be here. I was here last year too, actually. Very nice place. Thanks for hosting BuildETH, of course. Yeah, short intro about myself. My background is cryptography, PhD in cryptography. Has been Google for 5 years, leading infra teams. Before I started IoTeX back in 2017 with 2 other co-founders. Yeah, so I'm a very early kind of Ethereum community member as well. So yeah, so early to the game, which is good. So what IoTeX do is mostly focus on something called DePIN, decentralized physical infra networks. So it used to be called like a IoT blockchain, such a lame name, right? But like now it's fancier. It's called DePIN. So we're mostly like a builders in DePIN space. We provide a lot of tools. We have our own chain, the middleware for off-chain compute, as well as some hardware component SDK as well. So this is like a category, definitely like a gating on fire. Not too much related to what I'm talking about today. Okay, so then come back to this one, right? So why are we working on DePIN? I'm sorry, why are we working on AAA, account abstraction? So if you guys are coming from Ethereum, like a community, you should know like this has been a topic in Ethereum Foundation for really like a long while, and Vitalik is a big advocate for this one for sure. So it has a potential, to bring in like a next, I don't know, like a billion, millions of users, like a mount type or grand mount type of user who really cannot use a MetaMask, right, on everyday basis, but who can use maybe phone or email, some text message to, interact with the technology. So this has a high hope for that. I'm sure like Vitalik will agree with this as well. And specifically, why are we looking into this one, right? Because like I said, we're mostly in the DePIN IoT blockchain space. And one very interesting scenario we have in DePIN is there are usually some devices, right? So think this as it has pointer. No. Yeah, so think this as like a Uber car. Basically, like Alice owns a Uber car, and he just rented out autonomously using smart contract or whatever like a technology we have to Bob. Bob doesn't have the car, but use the car, So Bob pays to the smart contract, which eventually pays back to Alice, right? So in such a scenario, so we need the car to talk with the blockchain like autonomously. Of course, car maybe have an account, but the car cannot have a Ethereum in his account, right? In its account. So that's why we need a sponsored transactions for sure from Alice. Another interesting scenario is some like arbitrary verification or execution. Like for example, if you just like transfer the ownership of the car from A to B, if you want kind of like a limited spend on the gas fee on an everyday basis, right? All those like scenarios require some sort of customized execution logics. So that's why we're looking into AA. So this work has been like sponsored by Ethereum Foundation. Thanks for the Ethereum Foundation folks for sure. So we have like actually like 4 core members working on this one. 2 of them are actually from research team, and 2 are from my like a product team. So for you who don't have like a basic understanding about the AA, it's very simple, right? It basically allows you to use like an email or password or some other kind of very basic authentication mechanisms which you use every day to how should I say, to interact with the blockchain, right? To do a token transfer, to buy an NFT, to exchange on Uniswap, so on and so forth. And technically, so this is mostly how it works. Basically, a lot of so there is something called user operation, which is basically like a meta transactions, you can think, right? It's not yet a Ethereum format transaction, but it will be. So it's called user operation. For example, I want to send token to another guy. So all those like a user operations, so they're off-chain, so they just gets like a bundle all together by like a service. It's called bundler, right? So bundler is a guy actually, putting all those meta transactions together and convert them into like a Ethereum format transaction, then send it to a smart contract, basically called like an entry point. Entry point is like a Siglinton smart contract on every chain. So basically, it tells the entry point. So here it comes like a big giant, like a Ethereum transaction. Please process. Then this entry point will actually, breaking this entire thing down into 2 things. One is verification. Is user A actually user A as he claims, right? This is verification. The second is, what does this user A wants to do? Does he want to buy token? Does he want to transfer token? Does he want to do A, B, C, D, E, right? Then basically we'll call, different things and make the magic happen. And who pays for the gas fee? So here is a guy called a paymaster. Paymaster is another role basically in this AA world. It means like who is willing to pay for the gas fee. For example, this could be like a DAO, right? For example, if you're holding like a DAO NFT or token, the DAO will pay the thing for you. Isn't that good? Or like a Visa, so they have a recent work. Basically, they can hook up this paymaster with your credit card. So every time you do something on Ethereum, for example, IoTest chain as well. So your like a Visa card just gets charged automatically. So this is beautiful. All right. So this is about like the AA. And that's it for the presentation. No, just kidding. Yeah. Okay, seems working. All right, so here is like what we have done so far. So if you see like the orange blocks, so that's actually like a Ethereum Foundation granted us for at the very beginning. That has like an open source paymaster, on-chain paymaster, that has some like a zero knowledge circuits, which has some password-based authentication, which is actually the things we built in the past. But like recently, we also like extend to many other kind of authentication schemes as well, because we do feel like we want push AA to be like something real, putting the smart contract accounts into the hands of the real people. That's kind of like our mission. So that's the things we have done here. So today, I think there are like three major pieces of work I can show you. So like AA is not just a theory, it's become a product actually. So I can show you like a demo, which we use password, to control like account to claim an NFT. Another demo is we use like a passkey, which you all have on your phone, on your computer, to actually create account. You can do something A, B, C, D, E. And then I think most importantly is our live product is IOPay wallet. It's a 300K, like people actually using this wallet. So we recently kind of pivoted a little bit, to support AA. So more people will use AA. If you're interested in the work we have done, you can scan the QR code, which will link you to our link tree and has all the details inside. So this one is the first one, like password AA wallet. So it's a very simple one. Let me see if I can just do a live demo here. Usually demo doesn't work. Hopefully this time it does. All right. So now I'm here. I have my MetaMask connect to my IOTeX testnet. So this is like a fake token. The token doesn't worth anything. So we can put in like account name, like pretty much as you want to sign up on a website, right? So you can call whatever name you like. You can put in like a very simple password, 1, 2, 3, 4, 5, 7, 6. Then you just type login. Of course, this is a very weak password. And then you actually get your account created, right? So this is like nothing actually happens, in the view of a user. Once you have the account, what are you gonna do? So you can just like do an NFT very easily. I don't have any gas for now, right? I don't have to poke with my MetaMask for now. And then you can see everything kind of happens automatically. I'm already getting this NFT. To prove I'm actually getting the NFT, I think that's our like a kind of browser. So you can see like this is a claim NFT transaction, which actually happened a few seconds ago, right? So this is how easy this could be for for a user like your mom or grandma. That's kind of like a very simple demo. And next demo is about passkey. So passkey is like a new technology recently, right? In the past few years, I think Google proposed this one. Is trying to eliminate password. Password is not secure. It's hard to remember. If it's easy to remember, then it has a very low entropy, then not secure at all. So that's why they call the name passkey. It basically works like this. Every phone, if you use iPhone, Android, every phone already have this one. Is you have a private key, you have a public key pair. You store your private key usually in the secure enclave of the phone, and you cannot actually use the private key directly. So what you're gonna do when you log into some website like google.com is it will send you a login request to google.com, and Google will send you back like a challenge here saying like 1, 2, 3, 4, 5 or any random number, and you just like use a private key to actually sign this random number. Of course, everything kind of happens inside of your phone, the security enclave, right? Then you give the signature back to Google because Google has your public key, so Google can actually verify. Then everything works. So this is like a very simple, like how the passkey works. And we have also like I have another demo is basically enable AA to work with the passkey. So here is how it works. All right, so larger, right? So this is like another one. So remember this one is ending with 2E, right? I'm going to create like a new wallet here. So what I'm gonna do is I click this button and this asks me which passkey I want to use. I will use the one associated with my Chrome browser. And it asks for the fingerprint. I just put my fingerprint here. And now I have like a new wallet, right? So this is how you create like a wallet, like a MetaMask wallet. So very simple. And then you can use the wallet for like an NFT, for trading, for DAO, for like a yield bearing, like Connor was talking about, so on and so forth. Okay, so those two are actually demo, right? So let me show you something real. So this is a wallet actually our team has been built for the past maybe 3 or 4 years. We already have like a 300K users, global users use the wallet for for this many years. And it's very much focused on security and user experience. The reason we want to bring AA into the wallet is because of user experience, right? We agree with Vitalik and everything else. Do you have a question? No. Yeah, that's true. Yes. No, the password is different. I think for the password, they did like a password hash off the chain, right? They have a ZK proof for that password hash. Yeah. 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 Yes. Yeah. So that's kind of like a thing, like you're asking. So they have this security enclave. They have a different curve compared to Ethereum. So it's a different format of signature. But I think like Ethereum, they have a pre-compiled contract. They can verify this type of curve as well, signature of this curve as well. It's very efficient. That's true. Very true. Yeah. 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 But like IOTax chain actually supports this one natively, so it's very cheap on our chain. Anyhow, yeah. So sponsored like a transaction, like I talk about some account recovery, use email, which use DKIM protocol underneath. And also we make it like an open source, like SDK. So everybody, if you're building like a mobile wallet, you can actually directly use this one. So everything is kind of wrapped up in a very good way. And where is my controller, by the way? So here is like if you want to download the wallet right now, you can scan the QR code. So everything's live, right? So I'm not like lying. So everything is live. So if you download a wallet, you can actually create your wallet right now, basically. It will send you something for verification. It's a very much Web2 experience. And once it's verified, right? So you're live, basically. You're having you're having like your wallet alive here, and you can trade in whatever tokens you want. And who pay for the gas fee? So we build like a very simple DAO actually on our chain. So basically we airdrop like 2 tokens per day per user for them to getting started without worrying about the gas fee. And if they hold like a very special NFT, we give them more token, right? So that's kind of like a demo. Nothing too serious, but it's fun. Yeah, so next big thing, right? So we also IOP also have like a web version which hook up with MetaMask. So there are some talkings around how about we enable social login, social recovery for this web version of IOP. It also has this too many users, as well as some like password and passkey like authentication, like I just showed. Another work we're working with like it's similar to the what's it called, like a modular AA, right? ERC 6900. So we have like a more efficient, gas efficient implementation about the modularized AA. So I don't have too much time to dive into the details, but it's pretty much something like we're still working on. Yeah, all in all, so we are IoTex. If you want to learn more about the work we're doing, so definitely talk with me or follow us on Twitter. Okay, I'll just pause here for now. It's a multi-chain wallet, right? It supports Ethereum, Polygon, IoTex, Arbitrum, EVM chain, basically. Yes. All right. Any other question? Is a browser version? Yes. If you go to iopay.me, I think there is a browser version. Doesn't work? Okay. All right. So blame my product guys. Okay. Cool. Any other question?
I was looking at past keys of it a couple months ago, and it seemed like the result was not deterministic from like a contract. All the header data was correct, but there's some fun stuff going on under the hood that's not cheap.
Yeah. Yeah, I think it's a very cool technology, right? You just your biometric like authentications and you control the wallet. That's very cool. Yeah. All right. Oh, one more. Okay. Mm-hmm. Yeah. Yeah, high level 4337 is a ERC you should looking at, right? So there are some recent talks about, I think Vitalik is saying like we should enshrine this into like a native Ethereum chain. So yeah, there might be another like a EIP, I think maybe along the way. But if you want to look at like a ERC 6900, I think that's maybe something you're looking for. So they have like a modularized implementation about the verification, execution, so you can put hooks, in between, basically to implement some very customized logics. All right. Thank you so much, everyone. That's really cool. Yeah.
All right, guys. So we have Zahid and Cameron talking about Jutsu and decentralized front-end patterns coming up in this room. And then in the boardroom, we are looking at decentralized AI agent patterns with Dominic Stell from StatSet.
Great. Thank you. Hey, everybody. How's it going? From a raise of hands, how many of you have heard of a DeFi hack that has involved a front end in the last year? All right. Not that many, but I can assure you there's been a lot, and it's a pretty big problem. And so today we'll be talking about how to actually put front ends on chain that can actually be used to verify, like, you could be able to match the contract with the front end, so you know that you're actually using the proper contract and you're not getting kind of bamboozled. So my name is Cameron Dennis. I have been working in the Near ecosystem for the last 3 years or so. I run a company called the Banyan Collective. Been in crypto for about 7 years now. Primarily run a education nonprofit and currently focused on multi-chain tooling and decentralized governance. And so here with Zahid, you click next. Yep.
Hi, I'm Zahid. I'm founder of Jutsu. I have been building software for more than 12 years. And mostly in space tech and computer vision. Last 2 years, I have been mainly focusing on Web3. I believe in the intersection of Web3 and AI. So we're building a tool that will kind of bring that intersection of Web3 and AI.
So this is, I'm probably going to just talk for about like 5 minutes, give you guys a little bit of a lay of the land regarding this new sort of subvertical called chain abstraction. The whole point here is, L1s, L2s, L3s, honestly a road to nowhere. And if we're really trying to build Web3 applications or open web apps for the masses, we need to abstract the blockchain away from the user. And so, can I actually see the slide? So this is a quick overview of what the open web stack includes. And so if you look here at the top, there are actually, let's actually start at the bottom. Go at the bottom, it doesn't really matter what chain you actually work with. It could be Near, it could be Ethereum, it could be Polygon, the list goes on. And then the second layer is the data platform. So this is where all the indexers, oracles, data availability layer, that whole, I guess, part lives there. There is a new data availability product that was shipped by Near Foundation in the last about 3 weeks, and there's partnerships with Starknet and Polygon and a bunch of other platforms to actually store the data from their chains on Near to have one sort of a little bit more ironically centralized approach to making sure that data is available across different chains. And so the next piece is the discovery, and you kind of move up the stack to like the app layer and then the wallets for like asset management. And so we kind of call this whole thing the open web stack. The blockchains are really just a piece at the bottom. And so to actually enable this, we've partnered with Polygon to build a ZK WASM prover. So a WebAssembly based ZK prover, which will actually be able to verify transactions off chain and on chain. And the whole point here is actually to long term, it will be so you don't need consensus as much. I think the future of blockchain development and consensus is actually going to be mainly ZK based. And so this is a huge initiative put together through Polygon and Near to do ZK verification on WASM based blockchains much better. So that's exciting. And on the data availability product, there's been a big partnership with EigenLayer to leverage Near's fast finality. On Near, blocks can actually go on chain every second, and you can upload around 16 megabytes per block to the chain. And so this is super helpful for EigenLayer and is actually going to help decrease a lot of their costs and speed tremendously. And so I mentioned something about the security vulnerabilities around front ends in the beginning of this talk. And this is just like an example. Curve's front end was hacked last year. This was, oops, you can't see, but Kyber Network was hacked. This is not this one. This is a front end hack that happened last year. Balancer, same thing. Velodrome, same thing. And so what is the actual solution here? Well, we can actually start building composable on-chain React components. It's not exactly React, it's like JSX. But the idea here is all of these different sort of apps, the front end is complete, like all the JavaScript code is stored on chain and is completely composable. So you're able just to fork it instead of, and you can call contracts on any chain. So the idea here is like, instead of having to, fork Uniswap for 100th time, you can just take the on-chain component, change the CSS, and now embed this Uniswap component into your app. Now you have a decentralized exchange in your app. This is really cool because we're bringing what worked really well in Web 2, which was React, bringing a bunch of new front-end developers or lowering the barrier of entry, bringing that same thing to Web 3, which is super cool. And this is what Jutsu is building a platform to enable. But this is actually near.org's website. You can actually go and check it out. All of it is actually served from the blockchain directly, so completely serverless. And another kind of big partnerships that we've brokered is around Mantle. And so this is a gateway for you to use any DeFi app on Mantle within one dashboard. And we did the same thing for Polygon ZK EVM. And but this is an app called DapDap. DapDap is an aggregator of a bunch of different DeFi components across many different chains. And we heard earlier today about one of the main use cases in DeFi today, given that interest rates are high, is airdrop farming. And so airdrop farming is pretty much like one of the main use cases of DeFi today. And so what this is, I don't work for them, so I can say this, it's the best airdrop farming tool you can possibly find, because you can go from network to network within one dashboard, complete these quests, and just do this again and again and again. I've been doing this. I'm excited for my airdrops. Definitely check out DapDap if you are interested in that. But the whole point here is this is a proof of concept around the power of composability, multi-chain composability. So you can just take these different on-chain components and embed them so you can have, let's say, Gamma on Mantle in the same exact app as QuickSwap from Polygon ZK VM. So this is pretty much what it enables. It's single point of entry point, lack of fragmentation, and a streamlined developer environment. And that's exactly what Jutsu is here to tell you more about.
Okay, so I want to start with a question. Like, how many of you are builders? Like, build stuff. Okay, so half of the room. How many of you really write code? Okay, and how many of you don't write code but still want to build something or are building something? Perfect. So Jutsu is a kind of a, what we are doing is like we're building a platform focusing on both group who want to build, who can write code, and who also don't know how to write code, but still want to build. Before showing the platform, so this is what I think like an open web current state. So the way you probably, those of you who already build today, is you probably have to install and all the different frameworks locally, and you have to configure them, and then you use some sort of library like Scaffold or others, and then you build and deploy your front end, Web3 front end, where? In a centralized storage that can be censored by anyone. So you probably deployed in Vercel or maybe S3 bucket. So this is that creates some challenges. So the first challenge is it is time consuming to kind of configure everything locally. And if you are not a experienced developer, so it can take you days. Then the next challenge is, how many of you build like a same login or connecting wallet like a more than 3 times? Like every time you build an app, Web3 app, you need to write similar kind of code over and over. If you're building a lot of apps, like it become really not efficient. So like almost zero or no use reuse of front-end components. The other challenge is you saw the DapDap. So it is an app that bring data from multi-chain. So building a multi-chain app is very difficult. So if not impossible, it's possible, but it's like a lot of work. And at the end of the day, the main promise of open web is like building a totally like a truly decentralized app. But we are still front end is 99% cases it's centralized, unless some people do it in IPFS, which have some other problem. So that's for that we have a solution. We built Jutsu. So Jutsu primarily is a web IDE where you can write your code in JSX, in React, and then when you deploy in one click, you can deploy on a blockchain. Currently, we are using Near as a blockchain. Then if you are not a developer, because when we started this project 6 months ago, and then after going through several iterations, we found there are a lot of people who like to build stuff, but not necessarily programmer. For them, we also have a generative UI where you can go and you can write a prompt, and that will generate the UI. In the future, probably you probably heard about Cookbook and some other project in Ethereum. Probably you'll point to a contract, and then it will generate the UI for you. Then another big challenge that when we talked with people, we found there are not great way to discover like different apps in Web3. So we have a search engine that kind of index, and where you can search different apps. And then Jutsu also have live collaborations. So if you want to work with other developer in the same project, it's more like a Google Doc style, like a two or more people can work together. One of the most use case for that is like a learning platform. So when we run a lot of workshop, it's become super useful to kind of share this link and then co-create with other people. And then deployment. If you deploy in Vercel, they did a great job of deploying like just one command deploy in a centralized storage. But for decentralized deployment, it's very difficult. But for our case, you can just go and click that deploy button, connect your wallet, and deploy your code in on-chain. If you want to kind of follow along, then you can scan the QR code. Okay. So it will take you to a link tree, and then where you can follow different projects that we have. But the next few minutes, I don't know, there is a time somewhere. How much time will we have? Okay. So I just want to show the thing, like it's not just a hypothesis, it's people are using it. We have around 600 developers today, and almost more than 6,000 apps are deployed on chain. So it's not any more hypothetical thing. So one of the promise for open web is composability. So what I will do is like I'll go there and show the real real project, so that okay. Okay, so this is Jutsu. So where you can see these are all my work that are on chain. And then this is the place where you can search different apps. So this is a community-driven app store, kind of app store, where when people deploy their code or their app, so you can come here and search and you can use. So imagine like you want to build a Ethereum DeFi front end. So something like Uniswap. So you can come here and you can search like if someone maybe build something like Uniswap. So let's say like so now you can see like there are a lot of people build different version of Uniswap. You can come and you can fork that component that bring you the code and the UI here, and you can live update here. You can change your contract address, ABI, and then you get the UI. So the idea is like you can use other people's code and compose your own component. Then the next slide. So that's then the multi-chain story is like even this app is not necessarily you have to use a Near, so you can use Ethereum and other protocol. Then the deployment part is, so if I want to deploy this component, let's say I change something here, and then I want to deploy. So with one click, without any command line or anything, I can deploy. It will tell me how much it will cost. So these apps will cost me $0.8. So it's like a very cheap, like 8 cents. So so the concept of on-chain app will be expensive. It's not anymore true. So you can really deploy a real app with very cheap. Then the other thing that I mentioned, like where if you are not a developer, how do you build and deploy? So we started another project. We call it, it's a MVP. We call it Bentho, where you can come and you can type basically whatever you want to build. So there are some, it's similar like Vercel if you ever work with Vercel AI. So when you say like, I want to build a, create a login system with username and password, and then when you click, it will call multiple LLM and then parse that code and kind of compile and make sure it says front end is working, and then it will show you that code, and then in one click, then you can deploy that one in near protocol. So like it comes, it's not the best looking, but what you can do is like maybe I want to have a green background, so I can say add a green. Let's see. So the idea is like you can reprompt this thing and then gradually go to a stage where you can then deploy. So we are kind of trying to train our own model so that like later it understand Ethereum contract, and then from that contract it can generate the UI. So that's kind of the future goal with this project. So yeah, it's not again like so everything is generated by AI. So I did not have to write anything, and then you get the code. You can then open in Jutsu, and then you can deploy on chain. So if you want, so like that's the whole kind of the life cycle of truly decentralized front end. So these are just some example, but then we build some real projects. So one of them is this one. So Nearcon app. So it is a on-chain conference management software that was used by Nearcon conference last month. And we onboarded 2,300 people in the morning. Everyone got their own wallet, and we did it without any major issue. So like account abstraction, supporting 100 different type of mobile. So it was like a mobile, everyone used mobile app. And then we also built some experience where people can go around, buy t-shirt, buy food with and then those transactions. So everything happened without any issue, and the entire front end is on chain. So so that's a real app used by 2,300 attendee in Nearcon. So
And I would say like one of the coolest parts about this is all of these different pieces are composable components. Like you can just take this for your app, fork it, embed it, and change the CSS and deploy. So the whole point here is like, how do we create this like modular composable economy?
So and then the DApp, Cameron already mentioned about DApp. So the main thing to remember here is like these are all different protocol that are hosted in one app. So you can really build a multi-chain decentralized front end. So it's not anymore Dream or anything. What people are building now, DeFi, NFT marketplace, Web3 game, multi-chain, and consumer product. People are building on Jutsu using Boss. And what you can build, I think, start small, build some front end for your Ethereum contract, and then there are a lot of interest in ZK. If you can build any front end for ZK Sync, then there are also some grant that you can get. And then I think sky is the limit, whatever you can dream of. These are some resources that
I want to mention that we are actually hiring front-end developers who are familiar with Ethereum to build pretty much all the different gateways for the different L2 ecosystems that we plan to work with, which is everyone. And so if you do have experience, building front ends for things like Balancer or, complex DeFi apps, feel free to reach out to me. Here's just some resources. There's a great thread explaining this whole chain abstraction piece. There's a DAO dedicated to supporting builders in your ecosystem. It's called BuildDAO. You can go to nearbuilders.org. We're running a hackathon in January all about account abstraction called abstracting hacks. And that's abstracting.org. We'll send these out, I guess, after the conference, but 24/7 chat support, daily office hours, essentially everything that you would need to get the support. And last but not least, we run events very frequently here in the Bay Area. If you fill out this form and let us know on what kind of events that you would want to see, we have a co-working space on Folsom, and I know some of the people here work out of there. Shout out to the cookbook team. We run events there pretty frequently, and Zahid runs one of the largest JavaScript meetup organizations locally, and they organize about an event every month. And so feel free to scan this, let us know what you think, provide your feedback, and yeah, we'll love to hear from you guys soon. Zahid, is there anything you want to add?
We have time for question? No? Yeah, if anyone have questions, there is no need for a question, but
Yep.
Okay.
Any questions? Don't hesitate. We have a little bit of time.
Okay. Yes? No? Okay. Thank you.
Great.
Thank you so much, guys. It's very cool stuff. So coming up, our last talk of the evening in the main room. I see. So we're gonna end on main stage with a fireside chat with Don, Tyler, and Henry. Sorry, guys. Little change in plans. And we're calling it Arming the Troops. And then in the boardroom, oh, Henry's okay. So everybody's in. Okay. So we will be ending with that fireside chat here in about 2 minutes, 3 minutes. All right. Thanks, guys.
Dude, thank you, sir. And then I will
Henry?
grab our other distinguished speaker. Yes. All right. Come on in. We're beginning our final section. Thank you. Please feel free to join, guys. Yeah. All right. I guess I technically this is my panel. Yeah. I'll let you drive. Yeah.
We're here for you. You're good. Okay.
Thanks, guys. Moral support.
Yes.
All right, everybody. Happy Thursday. And more importantly, happy last panel until drinks and happy hour. Woo! So everybody, hello. My name is Don Ho, Managing Director at QuantStamp, a blockchain cybersecurity company. Instead of talking about what I initially wanted to talk about, which is smart contract design patterns, I figured it'd be a really cool way to end the day to almost put everything we learned and talked about today all together and why the heck we're even here. And so instead of talking about security, I think one thing that Ken talked about, Tyler talked about also is just what are the patterns we're seeing right now? And how do we put these technical patterns and marry it with actually what's going on in the market? And here, as everyone I would imagine is a builder. Well, hold on. Who here is a builder or a founder? Who here wants to be a builder or a founder? Let's go. Right? And so that's the whole point, which is how do you merge all this technical stuff you just learned with how do you build a company and how do you equip yourself for the next sort of what I call bull run, maybe. So I thought it'd be really awesome to combine all the sessions and also bring on some really cool co-speakers to really talk about that. I think a really good way to think about it is to start with what happened the last bull market to bear market and what do we anticipate now? Because I really do think history does not repeat itself, but it certainly rhymes and it certainly shows patterns.
And so perhaps what we want to do first is do a quick round of intros, and then I'll kind of guide us through what the heck we're talking about. But maybe Tyler, want to go for it?
Yeah, let's do it. So I'm Tyler. I'm the CEO of Cookbook. Started building it about 2 years ago. Don and I have known each other back from like 2019. And so Cookbook is a platform for developers to find smart contracts, protocols, and seamlessly build products with them, trying to make it much easier and more seamless for developers.
And I'm Henry. I'm the CEO of Starta. Starta is focused on solving cross-chain intents. And hopefully we'll dive into how intents are kind of changing the game here. And I started in crypto in 2021. And actually, I don't know if you know this now, but I started with the first post-quantum encrypted messaging protocol on Ethereum. And every time I spoke about sending messages on Ethereum, people are like, oh, are you building a bridge? And then that's how I got into the cross-chain space.
Amazing, guys. So, I still think we're in a bear market. I still think it's crypto winter, which is a great thing. And for anyone aspiring, or this is their first real winter and really into the first start of a bull, I think what would be really helpful is to figure out what happened or what kicked off the last one, and then what are the things we could learn about it. And I want to talk about in terms of perhaps the protocols and the different projects that kicked it off. So Tyler, want to go for it?
Yeah, definitely. Like in the last bull market, it was really a lot of DeFi. A lot of the DeFi was kind of very much in its early stages. So a lot of things were revolving around the ICOs, a lot of ICO booms. You had a lot of things in yield farming, a lot of things with sort of like very high APRs, APYs, and just a lot of like hype around like being able to earn a lot of money very quickly in this sort of like pump and dump sort of mania that actually kind of matured in recent years. I mean, you still see some of it, but it's really sort of like gone through a lot of maturation recently. And it's kind of like gotten this new sort of like layer of professionalism over a lot of the memes and sort of like purple colors and just a lot of the neon that you saw in 2021.
Yeah, and food tokens. What about for you, Henry? What did you see?
Food tokens.
Yeah. I'm a big geek of geopolitics and history and current events. I feel like everyone was just trapped home, stuck at home. And some people saw that crypto was a bit more exciting and always on compared to the stock market, right? I think there is a function of that. I also feel like there's a separation between, I guess, between the last cycle and hopefully the next one coming up, the promise of a dream and the realization of a dream. And I felt like in that last cycle, you saw all sorts of crazy ideas, but people didn't know what was possible, what wasn't. So people are just going gangbusters. I think someone raised $500 million to make movies or something, right? Like something crazy like that, right? And I don't think a token is even released. Like they got nothing. So yeah, I feel like as cycles go through, people, both sides mature, builders mature, but also investors and retail users also mature.
Yeah, and maybe the way I would actually look at it is this. In the 2017, 2018 boom, we were promised apps, we got L1s, right? In the, I'd say 2020, 2021 boom, we were promised scalability, but we finally got our first apps. I would argue that DeFi Summer was one of the first real ways I could do something with my Ethereum or with my shitty altcoins, right? Deposit into a smart contract, get some new token, and then rinse and repeat over and over. But what was that? It was a usable app. But I think where this gets really interesting, though, and this is the nuance I want to get into, is that last bull market, we were promised apps, but got DeFi. What do I mean by that? When I think about Compound, when I think about Uniswap, when I think about the most used apps during the last boom, those are still things my mom, dad, sister, brother, none of them are going to use, right? Like it's hard enough for our friends to try to set up a MetaMask account. How the heck will anyone set that up and then find a way to go to Coinbase, buy some Ether, off-ramp that into a non-custodial wallet, and then put that into like a Compound? That's like really, really hard. And so I think what we got last bull run was not apps, but we got some early signs of like what you could do with crypto, but from a figurative perspective, from a command line interface, right? Like No one's going to use Compound in the future. People are going to use Chime or any other fintech app, and Compound is embedded. They actually have no freaking clue they're using crypto. And so I think that's really interesting, bringing it all together again. Is today what we learned is all these awesome design patterns, security patterns, cross-chain patterns that allow us to make things composable. But it's all to the end game of making stuff people want. Let me use another reductionist example. When I click the like button on Instagram or on Facebook, do I really care if Instagram or Facebook are using AWS or GCP or Facebook's own servers? No. All I want is to click that like button. All I want to do is DM that person I really have a big crush on, right? That is where we need to go as a community of builders in crypto. I think you probably definitely have some insight on this and why that matters cross-chain.
Absolutely. I don't think the average person wants to use a bridge. Who here has used a bridge in the last month? All right.
No.
Well, hold on. Who here used bridge? Yes, but who here used it reluctantly? Oh yeah, exactly.
Here's a better one. Who has had a transaction stuck on the bridge? There we go. Right. And so that's an awful experience. And when you think about bridging, I think of it from as a, if you're bridging to a new chain, that is your first experience with the new chain, right? So imagine the welcome mat is, I'm not home, come back like in 15 minutes or 3 hours. Or if you're using multi-chain, never.
We're
right?
fucked. We're so fucked.
We're closed now, sorry. And so that needs to be abstracted away from the user. It's not to say that bridges still aren't being used under the surface. They could be, they might not be. You know, a lot of native to native transactions that involve optimistic atomic swaps might not need to use a bridge at all, for instance. But an interesting thing is just like, how do we, I was using, there's actually some good smart contract wallets that are coming to the forefront now. Paymasters are being discussed. Account abstraction, you know, is kind of up in the air. And so it's interesting if you can just make it like idiot proof, to your point, or the average person has no idea they even used a bridge, or they just like, I want to use this app that happens to be on this chain. Oh, I just tap it and I'm done. And that's the magic we need to get to.
I also have another question regarding that, which is your Venmo wallet, your Google wallet, your Ticketmaster wallet, Apple wallet. Do you guys know the technology behind it? I have no fucking clue, right? I just know there's this thing, it holds my money, and I hope it doesn't go away. That is like the gap we need to fill for crypto, right? Again, that's the opportunity. I have this evolving thesis and why I love it for Quantstamp. We're going to audit all of it. But like the way I think about it is in the future, and I say this with love because we're here, but like in the future, Web2 devs don't want to have to use graph tokens. They're not going to want to use Chainlink tokens. They're not going to have to want to interact with every single freaking protocol to go build a web, like an internet website, right? They're going to want to use AWS, who's got S3 buckets, who's got Lambda, who's got EC2, who's got all this shit all under one roof. I think a big opportunity if people are thinking about starting companies or thinking about investing in types of companies, this is like the lamest thing ever, but it's going to make so much money. It's the middleware-ification of all of these protocols. Everything, right? The same way we think about, like Sequoia just put out this article saying, we believe AI is great, but we also believe we need to get to 1 million devs. Well, shit, if we onboard 1 million devs, they're going to need to have a lingua franca of how to develop or integrate all these things into their app, right? Because they're not building Web3 apps. They're building apps that happen to have a piece of crypto in it. It's the same thing with saying, I don't have an AI company. I got a company that uses AI that delivers an experience so much better. And so my hot take in all of crypto is we don't need an iPhone moment. We don't need a Netscape moment. We need a ChatGPT moment. Because what I mean by that is before ChatGPT, if you're an AI company, right, you had to be like some ML expert or some AI expert or some math expert in order to do an AI company. But with the launch of OpenAI's API, like I can be a lemonade stand And if now I can deliver a way better lemonade recipe for you, that's awesome. I'm not an AI company. I'm just a lemonade company still, right? And I think for all of us here, that's the thing we need to overcome and tell everyone about, which is, no, you're not building a crypto company per se. Sure, you're building a protocol or something that doesn't exist yet. Sure. But most of us here are building applications that developers or end users want. And some part of that will have crypto to make it more awesome. Here's a really cool example that Tyler and I were talking about before this panel, which is, gee golly, why doesn't Venmo in-game exist right now? Why can't I, as a clan member on League of Legends, send money to other players in my club or clan or whatever it is? Well, shit. It's because League of Legends needs to obtain a money transmitter license. Why the heck would they ever want to do that and not just be a game? Ta-da. What if some awesome entrepreneur, maybe in this group, found a way to make the Gnosis safe an SDK that any game company can use? And what happens is when I send money from me as Moo Hey, my game username, to Cookbook Dev, you know, the other game user.
I'd have a different username.
but when I have the ability to send him money, when I click send, that actually is a 1 of 3 signature. And then when I click send, the game is the 2 of 3 signature. What is the insight? The game never has full custody of the funds. If they never have full custody of the funds, they don't need a money transmitter license. Does that game now become a crypto company? No. But it just integrated Venmo for its game users, and holy shit, right? Maybe daily active user percentage goes up. Maybe GMV on the platform goes up. Maybe now the game can introduce a marketplace where gamers can buy shit and sell shit, but the game is just software still. That is the magic of why we are here today, why this conference existed, and what we need to do to educate not just the devs, but all of our fellow founder friends about what this future looks like. But Tyler, I know we've been talking a lot. You have any thoughts around any of this and where Cookbook maybe comes into play?
I don't know. I kind of like that bridges have docs pages. You know, I always thought that when I brought coins from one chain to another one, that I really definitely need a guide on how to do that. You know, I think that's pretty good developer experience. You know, from a dev myself, right? That's kind of like what you'd expect, right? I'm just gonna wait until like somebody responds. That's everyone's favorite user experience, right? How many times do you have to read the docs before you get it? If it's less than 3 times, it's not good enough. Okay.
You know, IKEA should start making bridge docs. You know, I think that should.
Oh man,
be the mom bridge.
Someone needs to make a protocol called IKEA as a service, you know, and you can incentivize the IKEA manual makers to make technical docs, maybe.
Yeah, I don't know. I think everything's great right now. We don't need to do any of that. I think everything's perfect right now. We don't need better UX. Everyone
Lies.
agrees, right?
Lies. No, I'm gonna shortcut it. This is why you should use Cookbook. This is why you should use all the stuff that we're all promoting. But more importantly, because we're 3 minutes away from beer, we just really want to encourage everybody here to take what they've learned and really start thinking about who you are building for. And if you're saying you're building for other crypto people, I think that's like you sitting at the little kids table during a dinner party. You want to be creating products for the world. And crypto is one piece of that product, but it is not the product. Put another way, the best technologies in the world put the product up front and make the technology itself invisible, right? That's why, for example, Web 1 didn't take off until Web 2, right? I'm not saying Web 4 is going to do that for Web 3, but we definitely need
Might be Web 5. Ask Jack Dorsey.
Yeah. You know, but we're gonna need something like Web 2 that
When is Web
middlewares it.
69?
What is it?
Web 69. Web 69.
You know, whatever. You know, there is an EIP 6900. Interestingly enough. But that being said, we just need some Web 2 mindset to centralize some of this stuff. And this is heretical. I get it. But certain parts of crypto, I think we've over-indexed on the decentralization scale. And that if we want real usability, there are specific trade-offs we're going to have to take on the usability side to ensure that my mom, my future grandkid can use this stuff.
I'm going to steal a point from my friend Chris Lyons over at Andreessen, who I think gave this talk in ETH Paris. He was talking about like how we should bury the wires. So essentially, like there's two. If you can see, like if it's like this exposed brick building where you can see all the plumbing, it might just be like too unappetizing for the average user because it's too complex. I'll also add though that abstraction is risk. So high value transactions, I think, should still be more carefully looked at. I think that's the responsible thing to do. But if you're playing like a game and the total value of your wallet's like $100, I'll give you a good example. Like Reddit's done some really interesting stuff before. I don't know, they kind of backpedal a little bit from it, but like they've created a lot of crypto wallets for a lot of people without them even realizing it. And I think those applications and I think it was fairly self-custodial as I understood it. And I think that's a great stepping stone for people to understand, like, oh, this is how I can leverage crypto without even realizing I'm leveraging crypto.
Agreed. Another one to share is like Republic.com. Republic is a crowdfunding service. They're awesome. They're about to literally integrate an MPC wallet on Republic.com, not Republic.com/crypto. It's Republic.com. But guess what? When you look at the top right-hand corner, it's not going to say connect wallet. It's just going to say account. The same thing we all know and love. And inside the account, it'll show you all your paper stock certificates of how many shares you own. Guess what it is on the back end? They're tokens, right? This is the sort of abstraction that I think is going to be really cool that people have no freaking idea is going to happen.
Exactly. And all jokes aside, it's something where in a couple of years, the process of building an app and building a dApp are not going to be different. You're just going to be using SDKs directly in your app, interfacing with crypto. Maybe the developer will realize that they're using crypto in some way, but even then they won't understand the depth of it. All of these infrastructure companies, all the compounds, Uniswaps, all of them will all become really just middlewares that you can just plug into any app, use in any application for any use case. You'll go to Facebook and you'll be able to interact with the blockchain without ever knowing it. And Reddit is maybe even the early example of what this could look like. But Reddit's that's still pretty bad. Like we got to do way better than that. But I think we can. So yeah, I'm looking forward to that.
This is awesome. Who here wants to do questions? If not, we can just go straight to the happy hour too. Are there any questions? Okay. Well, I think this ends the programming for BuildETH today. We thank you all for coming out. And certainly, if you have any questions about anything we're doing, please find us. And hey, enjoy Crypto Winter.
Have a good night, everybody.